history of Earth.
Mm-hmm. Did it happen more in the ground, or do you think it happened above ground, or both, or?
We don't know yet. I mean, the leaning evidence, from the Dawkinses and everyone else working on this is, undersea hydrothermal vents, but we don't know.
Mm-hmm.
Carolyn had a wonderful definition of the late heavy bombardment. She
Mm.
said there are two major episodes in Earth's early history. The first was when the planets were forming and comets were helping to build the Earth.
Mhm.
And the second was the late heavy bombardment, when the Earth
Mhm.
got the stuffing knocked out of it.
Mhm. That's beautiful.
Yeah,
And
never
of course,
forgotten that.
now we know that comets and icy asteroids, during that period did contribute a lot of water that ended up in the oceans.
Yeah,
Mm-hmm.
and in my glass,
Yeah.
my coffee.
Yeah. Let's see. Bob is signing on. So if you're listening right now, while we're so-called backstage, we have David Eicher from Astronomy Magazine, David Levy from the Jarnac Observatory, comet discoverer and author, and I guess David Eicher is also quite an author himself, and myself, Scott Roberts, and Robert Zellum. I'm sorry. Does that happen to you a lot, Rob?
Yeah, it does. No worry
It
about it.
does. I'm sorry, dude.
No
Anyhow,
worries.
we really admire what you're doing, and so it's almost
Hello,
6
Rob.
o'clock.
Hi, Rob.
Yeah.
How are you?
Good. How about you folks? Thanks again for having me. Really appreciate it.
It's our pleasure.
So I'm supposed to give a 5-hour presentation, right?
Yeah, it's 5 hours, give or
Perfect.
take 5 minutes.
Sounds good.
All right. Let's see. Make sure we are broadcasting live. It looks like we are. See that Mike Wiesner from Arizona has signed on. Matthew Oda from Phoenix, also Arizona. Matt used to live in Southern California. We did some astronomy outreach things together, and I did some astronomy outreach things together with Mike Wiesner. And so all my friends are here. So that's awesome. Well, it is 6, so let's go ahead and kick this thing off.
NASA's Hubble Space Telescope has looked for evidence of atmospheres around several Earth-sized planets in the TRAPPIST-1 system, including 3 that are in the star's habitable zone, where liquid water could exist on the surface. A lot of astronomers and space enthusiasts were very excited by the discovery of the 7 Earth-sized planets of the TRAPPIST-1 system. The planets orbit an ultra-cool dwarf star about 40 light-years away. Scientists have theories about what these planets may be like and whether they could support life, but we won't know for sure until we get more comprehensive observations of this system, including data on the planet's atmospheres. As a planet in the TRAPPIST-1 system passes between us and the star, it blocks out a small portion of the star's light. Telescopes like Hubble can look at changes in specific wavelengths of light, which provide clues to the composition and size of the planet's atmosphere. Hubble observations in May 2016 of TRAPPIST-1b and c showed that these planets do not seem to have thick, puffy, hydrogen-rich atmospheres. This indicates a higher chance that they are rocky, terrestrial planets, rather than many gas giants. Hubble then observed planets D, E, F, and G in December 2016 and January 2017 in near-infrared wavelengths, and the results were similar. Hubble found no sign of thick, puffy, hydrogen-rich atmospheres for any of the 4 planets. The data suggests that there is not this gas giant-like atmosphere for planets D, E, and F, and the data from this round of observations was not as strong for planet G, so while there's no evidence for a thick hydrogen-rich atmosphere on G, the researchers are not yet ruling it out. Planets E, F, and G orbit at distances where temperatures would allow for liquid water, while D is likely a little too hot. Hubble has yet to take observations of planet H, which is outside the system's habitable zone. To summarize, Hubble has not seen evidence of thick hydrogen-rich atmospheres for planets B, C, D, E, and F, and of those 5 planets, E and F are in the habitable zone. Planet G needs more data, and Hubble has not yet looked at planet H. It's worth noting, though, that even the planets outside the habitable zone still might be able to have liquid water somewhere on its surface in certain conditions. It's also worth noting that if any of these planets have high-altitude clouds and hazes, that would block Hubble's ability to detect a thick hydrogen-rich atmosphere. But such an atmosphere is not likely to exist on these planets. Many possibilities remain for what types of atmospheres these planets have, or whether they even have atmospheres. The TRAPPIST-1 planets could have compact atmospheres similar to Mars, Venus, Earth, or something entirely different. Researchers hope to use Hubble's ultraviolet capabilities to look for evidence of water vapor or methane, and NASA's upcoming James Webb Space Telescope will look in the far infrared to further characterize these atmospheres. Future telescopes also hope to look for hints of whether the planets are habitable and if life could be present. The TRAPPIST-1 system provides the best opportunity we currently have to study Earth-sized exoplanets. Over the next few years, Hubble and other telescopes will work together, each contributing important observations, so for the first time ever, we will have an in-depth understanding of a set of terrestrial planets outside our solar system.
Hello, everyone. This is Scott Roberts from Explore Scientific and the Explore Alliance, and you're watching the 135th Global Star Party. Our theme tonight is atmospheres, and I'm really happy to bring on some new guests and some regular guests. And I think we're all just happy to be back on Global Star Party. I can see many of you watching on in chat there, and it's a lot of fun to have our old friends there as well. So thanks for tuning in. Tonight, we are going to talk the subject of atmospheres. I mean, here I am breathing. I'm not even giving a second thought about it, but you know, if you do, you start to think about the chemical composition of the atmosphere that we breathe. And, you know, how did that come to be? You know, we haven't always had an atmosphere that we could breathe on this planet. I think it only goes back 500 million years, which seems like a long time. And it is a pretty sizable chunk of Earth's life. But you know, it is not at all the majority of its life. And so, you know, how did life spawn here? You know, what will happen in the future, you know, with our atmosphere? You know, these are things that scientists do study. And but you know, one way to also look at what might happen here on Earth is by looking at other planets, and that is part of the, I think, very intriguing part of looking at the study of exoplanets is trying to understand the signature of their atmospheres. And so, so we're going to talk a little bit about that. We have David Levy is up next. David, of course, is our old friend, certainly my old friend, and he has been patiently waiting several weeks while I made my trip into China and then came back to get ready for this particular event. So, David, thank you very much for coming on to Global Star Party, and I'll turn the stage over to you.
Well, thank you, Scott. It's good to see you again. It's been a while, and it's good to be back with this, our 135th Global Star Party, with the theme of atmospheres. Tonight, I offer two short poems, the first of which describes a prediction for what our atmosphere might look like now, but this poem was written in about 1870, called The City of Dreadful Night. And I think he's predicting what the atmosphere is going to look like in the present time. The comet hanging o'er the waste, dark seas, the messy rainbow curved in front of it, beyond the village with the masts and trees, the snaky imp dog-headed from the pit, bearing upon its bat-like leathern pinions.
I don't want to mispronounce that again. But Rob was very kind to come on to our program. I had an early interaction with him when he was first starting up a program called Exoplanet Watch, which is a professional amateur collaboration where they were looking for amateur astronomers to help them look at the data and to identify more exoplanets. I'm sure that Rob will give us more details on this, but he is a distinguished exoplanet astronomer. He's right now with JPL NASA, and I believe working out of Pasadena. He's been on several missions, space exploration missions, including like the Origin Space Telescope and HabEx program, which is something that I think all has to do with trying to find our way to create habitats in space. Correct me if I'm wrong, Rob, but you have a very impressive resume, and I'm glad to have you on to Global Star Party.
Yeah, thank you so much for having me, Scott. Thanks for that really nice introduction. Your check is definitely in the mail. Really appreciate that.
Oh, really?
I'm Rob.
Thank you.
I'm an exoplanet scientist at NASA's Jet Propulsion Laboratory out here in Pasadena, California. And hopefully that's showing okay. You're seeing the
That's
correct
showing
version of the slides
perfectly.
as well. Great.
Yep.
So yeah, like Scott gave that very nice intro. I'm part of a team that has launched this project called Exoplanet Watch, which is a professional amateur astronomer project to observe exoplanets, planets outside of our solar system. So as some of you might know, one way to observe exoplanets is to leverage something called the transit method. So if we're observing a star, if we're really lucky, that star will have a planet orbiting around it. And if we're even luckier, the geometry is just right where that planet will pass in front of the star, blocking out some of the star's light, causing the star to appear to dim, and effectively the planet is casting a shadow all the way to here on Earth. And from this, we can actually detect the existence of exoplanets. And the transit method in particular is extremely powerful because not only does it allow us to discover new exoplanets, it also allows us to measure their size, because the bigger the planet, the more light it blocks out from its host star. But we can also use typically large space-based observatories and also some ground-based observatories as well, such as the Hubble Space Telescope, such as the James Webb Space Telescope, which has been doing transformative science with every single new observation that it makes. And then there's also an upcoming mission called the Ariel mission. This is a European Space Agency mission that's launching at the end of this decade. And this will be dedicated to looking at the atmospheres of 1,000 planets.
Wow.
So these 3 space telescopes can actually leverage transit observations to actually characterize the atmospheres of these exoplanets. What they effectively do is they look for when the planet passes in front of the star, and they look for when the small annulus or layer of the planet's atmosphere absorbs some of that star's light. And from that, they can actually back out the composition of these planets. But in order to use any of these telescopes, or any telescope in general, to observe a transit, we need to know precisely when that transit were to occur. Otherwise, we'd have to build in lots of observational overhead to guarantee that we observe that event. But this is where our project Exoplanet Watch comes into play. We can help using small ground-based telescopes, 4.5-inch scopes, roughly 8 centimeters or larger, can be used to observe these transit events from the ground, update their timings, and then that way we can use Hubble, James Webb, and Ariel as efficiently as possible and hopefully maximize their science case. And any of you watching this program today can participate in our project and help out. So this is what led us to launch Exoplanet Watch, a citizen science project to routinely observe transiting exoplanets to help keep these timings really fresh. And by doing so, you can help enable additional NASA science. We are a collaborative effort to complement existing surveys. All of our data is immediately public, so you can go onto our website right now and get our latest results. We also have target requests by professional astronomers. So they'll say, hey, I'm about to observe this target on James Webb or Hubble. Can you help us out? And we've been doing some campaigns with them. Also, if you contribute a data set that is included for the first time in a published paper, you'll be listed as a co-author. If you do the work, you deserve the credit. And we are funded for the next few years by NASA's Universal Learning. So a huge shout out to them for supporting us these last few years.
Yeah.
As a citizen science project, we have both science goals and educational goals. The science goals, largely what I talked about before, to ensure the efficient use of large telescopes. Also, we're starting to getting more into the discovery and confirmation of new exoplanets. And one thing we'll be starting very soon is the monitoring of stellar variability, because that's really important for interpreting these exoplanet atmospheric observations. But for our educational goals, it's to engage and teach the public about exoplanets and enable them to do science, and hopefully to inspire the next generation of folks to enter STEM fields, much less astronomy. So what I'll do really quickly right here is this is a sort of a quick roadmap or overview of a user experience. It's a little overwhelming at first, but I'm going to step through it in pieces. So let's pretend you're someone that despite all my bad dad jokes and Star Wars references, you still want to join our project. If you have your own telescope, what you can do is you can go on our website, enter your location on the Earth, and it can tell you recommended targets to observe any given night. That being said, you can observe any target you want. We'll accept data on anything, even a target that folks have been observing the last 20 to 30 years. Then once you plan your observations, you then go out and use your own telescope and do observations. Well, let's say you don't have your own telescope. That's not a big deal. We actually have a data request or a data checkout system. We have been very kindly donated about 11 years worth of archival data from the Micro Observatory. This is a robotic remote telescope, a 6-inch telescope in Tucson, Arizona, here in the Southwest United States. And they've been observing transiting exoplanets for the last 11 years, and they've donated about 2,000 data sets for our users to use. So if you want to participate in this project, you don't have to have your own telescope. You don't have to live in clear sky locations or even try to buy a cloud filter. You can just go on our website, request some new data from us, and then you can fully participate in this project. Then, once you have your data in hand, either by taking your own observations or getting it from us, you analyze your own data. So you actually take those images and analyze them and produce science-grade data sets. There's a lot of different tools you can use. Astro Image Day is a very popular one among the amateur astronomy community. We also have our own exotic as well that I'll be talking about in a slide in a second. Once you then analyze your data, you upload it to the AAVSO. The AAVSO, or the American Association of Variable Star Observers, has very kindly allowed us to use their database for free. And this was really key for us because for some reason, JPL and NASA doesn't want members of the general public randomly uploading data to their servers. So it's really great the AVSO is letting us use this as part of our project. You upload your data to there, and then you kind of sit back, relax. You can publish your own results. You can also go on our website and publish results that are currently on our website as well. And some of our users have actually started their own scientific collaborations as citizen scientists and have published, I think we have about 5 to 10 first author papers by citizen scientists that are peer reviewed that have been published as part of this project. So I mentioned exotic. This is our exoplanet transit interpretation code. This is a real astronomy analysis tool. So this is literally the same exact code that I use as the professional astronomer to analyze my exoplanet data. The only difference between the version of exotic that all of you might be using versus me is that we have a more friendly portal to interacting with the software. This runs in either 2 ways, locally on your own computer, or we recommend people run it through a Google Colab. So basically, you run Exotic through a web server, and then the information and the computers are all churning on Google's side of things, and it's completely free. And in as little as 4 minutes, you go from your raw data into a final light curve that looks like this that you can submit to our collaboration, or you can publish as well yourself. We have lots of step-by-step tutorials on how to use these as well. And we have a very friendly and helpful Slack community in case any of you have questions at all. I mentioned also a little earlier was our observing campaigns. One of our largest, most successful ones was back in December of 2021. There is an upcoming program using the James Webb Space Telescope to observe this transiting exoplanet. The only problem is this transiting exoplanet has a very long orbital period. So the transit event takes anywhere from 12 to 18 hours to observe from front to back. And it's literally impossible for a single observer any place in the world to observe this full transit. So what we did is we talked to our user base and got tons of folks super excited. And we effectively simulated a large worldwide telescope, very similar to Las Cumbres Observatory, made up of our users. So we had folks, for example, in Eastern Asia start to observe some pre-transit baseline of the transit. They handed it off to folks in India, to Eastern Europe, and then to the west coast of the US, and then back to Eastern Asia. And we were able to stitch all those light curves, all those individual data sets together to make a single light curve. So this really shows the power in numbers that we can bring by having tons of amateur astronomers across the world to participate in this project. In addition, though, we had 24 facilities that participated in this project, all relatively small scopes, none larger than 30 inches, and most of them were about 4.5 inches or about 8 centimeters across. But as luck would have it, Mother Nature decided not to cooperate that night, and most of the northern hemisphere was actually clouded out. So we probably had another 20 to 30 astronomers who wanted to join in this campaign but were clouded out. So this really shows why having a large distributed network of users can really be crucial to helping out. And as a result of this study and our amateur astronomers that participate in the study, we were able to save the James Webb Space Telescope about 3 to 4 hours of observing time on this one target alone. And if you do the math, and depending on how you count, an hour of James Webb time is anywhere from 100,000 to $1 million US. Wow. So maybe we saved 300,000 to $3 million. So if any of you know some big NASA muckety mucks, feel free to ask them to write me a check. That'll be a really nice bonus at the end of this year. So that's my quick little spiel about Exoplanet Watch. If you are interested in getting started and involved in this project, we'd absolutely love to have you. You can either memorize our URL here for our website. You can also scan that QR code with your cell phone, or you just Google NASA Exoplanet Watch, and we should be one of the first, if not the very first thing that pops up. And also this QR code still might work. This is a workshop that we ran back in January of this year. And I think you can still access the recording on how to use Exotic to analyze your data and fully participate in this program. So with that, thank you so much for having me, and I'll stop right here. Thanks.
Oh, that's fantastic. That's fantastic. There is, there was a question which I think you answered several times about the type of telescope or how large of an aperture, that it would take. You said roughly 4 inches, but is it, are there any particular telescopes? Should they, obviously, they should be able to accept a camera. Are you doing any, there's no chance of doing any visual work in this range?
Yeah, I'll answer the visual question first. So the transit events, at best, we're looking for 1% dip in brightness of these host stars. So it's very,
Okay.
very difficult for the human eye to see. So I've always been amazed, though, about the size of telescopes that folks have been able to use to observe transiting exoplanets. For example, I saw online a few years ago, someone posted in an astronomy forum how they used just a single DSLR camera on a very basic barnyard tracker to observe a transit.
Wow.
The smallest data that I've personally seen routinely are with 4.5-inch telescopes. So some of those, I think, were the unistellar EV scopes that
Right.
folks have used, and they are producing some amazing data as well. And the micro observatories, a 6-inch telescope, 10-centimeter telescope, those are routinely producing great data as well. You can use an alt-as mount for this.
Mm-hmm.
The observations typically could take about 5 to 6 hours, give or take, on any given night, depending on the target.
Yeah.
Alt-as might have some tracking issues. We've experimented with like an
Field
off-diagonal.
rotation problems.
Well, field
Yeah.
rotation, actually, we can completely tolerate it. Our
Okay.
code is able to easily counteract that, actually. It's more about just keeping the star somewhere in the field of view and some nice comp stars in the field of view as
I
well.
see.
So
I
an
see.
equatorial makes life easier.
Sure.
But if you only have an alt-as, it's not a big deal. And also, they sell some really nice astronomy cameras for relatively cheap these days, too.
They do. They do. I've been looking at them myself. So that's fantastic. I know that there's some people watching that will want to join and try it out. How hard of a learning curve is it for somebody that's just a beginner? I mean, they're just going, yeah, I'll do it, and they don't have like a. I know the Unistellar science team kind of makes this real easy, okay, but if you got to, if you're kind of going through the steps from zero to actually being able to submit something that's worthy, how long do you think that takes?
Yeah, so some of our users are up and running. If they don't have their own telescope, they're getting data from us in as
Yeah.
little as half an hour to an hour.
Wow.
Sometimes you can get some folks that can get in a few minutes. We also have a very active Slack community, just like Unistellar does as well. And I'm on there all the time. And we have lots of other friendly team members and citizen scientists who'd be more than happy to help you and step you through the process as well. So if you do get stuck, let us know. So that's something we can improve on and fix on our end to make it even more user friendly. And then those of you who are astrophotographers out there, if you can do astrophotography, this is like so much easier in comparison because you don't need perfect tracking, you don't need perfect guiding, you don't need perfect focus. You just need to get those photons. And
Right.
even I can do it, and I'm a horrible astrophotographer. So
Well, I really appreciate you coming on, Rob. You responded really quickly to my request, and I'll try to get the word out as much as possible. I did put a link into the chat, okay, that they can just directly link on or click through on, and hope to have you back sometime so we can talk about the successes of your program. So.
cool.
Yeah.
Yeah, thank you again for having me. Really appreciate it, and have a good one, everyone. Talk to you all soon.
Thanks. Take care. All right. Okay. All right.
I would
So,
like to interrupt at this point.
okay. Yeah. Hold on for a second, David. Let's put you on here. There you go.
Thank you. Thank you. I've just noticed that Steve Edberg has just joined us.
Yes.
And I want to give him a real introduction. Steve and I are very close friends. We've known each other since the International Halley Watch. He was running the Amateur Observations Net
That's right.
back in the 1980s. We got to be very close then. and we've retained our friendship. It's been a while since we've been in touch, but the friendship is still there. And I'm so glad that he's with us this afternoon. Just wanted to say that. Welcome,
Yeah,
Steve.
yeah. Yes, that's right. Okay. All right. Well, he's coming up here pretty soon. So,
Thank you, David.
yeah. And I actually participated in International Hadley Watch. So we might talk about that just for a moment when you come on, Steve. Okay. By the way, very dramatic lighting you got on there. I like that. Okay. All right. So
You'll see why.
So up next is David Eicher. David and I got to spend some time together in Chicago to see, to watch Brian May, doing his other job, which is being a rock and roll musician. And it was, if you haven't seen the Queen show, didn't get a chance to see the Queen show, here, you might have to catch them in Europe, but definitely worth watching. And I think there's some videos out there of some of the live activity going on with his show right now. But at 77, and I don't think
76.
Brian May's watching Global Star Party right now, okay? But if he is, I want to say I'm really, really impressed with what you can do up there on the stage, So there's probably a lot of 30-year-olds that could not keep up with that. So anyhow, so we're back with Dave Eicher from Astronomy Magazine. He is the editor-in-chief of the magazine there. His whole life has been centered around educating the public through his writings, through getting other people to write articles and publishing those articles, collaborations he's done with his books, and books he's written just all by himself. But Dave has been deeply involved in educational outreach on so many deep levels now for several decades. And and it seems like he never gets tired of it. And he's taken this up to another level with Starmus, which includes Brian May and a bunch of other people that if you are interested in rock and roll, if you're interested in science, you're going to want to go to this event. And Dave Eicher is now kind of one of the leaders of this whole program. So he can give you all the insight on that. But right now, we're going to turn to Dave's exotic universe, or deep sky objects.
Thank you.
There we go.
Thank you, Scott. And it's great to be back with you and to have the Global Star Party going again. And thankfully, we both survived Chicago.
Yes.
So I will share my screen and I will see if I can share a deep sky object and start this slideshow. And if we have the Centaurus A, that we're in the right universe, but we don't have the right object, because tonight I want to talk about a different galaxy, and that is, we're still at a very high latitude here in the northern sky, working our way southward. And I'm afraid that we still have more than 400 objects to go in this march onward. But tonight is actually, for a challenge object, is actually a fairly bright galaxy, NGC 6946, that's pretty well known by a lot of observers. It's sometimes called the fireworks galaxy. It lies literally on the border of Cepheus and Cygnus, and it's called the fireworks galaxy in large part because it's a very notable producer of supernovae over the years. But it's a face-on galaxy. It's almost exactly face-on to our perspective. And so it's a really interesting object, especially if you have, an 8 or a 10-inch scope or larger in a dark sky. You can see some really nice detail in this galaxy. So it's a good one to have on your observing list. It's an intermediate spiral, not quite a barred spiral. It was discovered by William Herschel in 1798. It's about 25 million light years away. So it's close. It's about halfway to the gravitational center of the Virgo cluster from where we are, and 2.5 times farther away than the diameter of our local group. So it's relatively close to us in the universe, which gives us that great detail. As I mentioned, it's one of the best face-on galaxies in the sky. It's about a 10th magnitude object overall. And as I said, it's a poster child for supernovae. So there are supernovae that have occurred in 1939, 48, 68, 69, 1980, 2002, 04, 08, and 17. So there are at least 10 times the production of supernovae in the Milky Way. As you guys, the observers and astroimagers both might know, we're sort of overdue statistically for a supernova in the Milky Way. Most of the supernovae in this galaxy have been magnitudes about 11 to 16, so easily imageable by amateurs. And there are many, many past images of good supernovae in this galaxy that people have taken over the years. It's a bit of a starburst galaxy, sort of on the edge of that definition, because it's got a relatively high production rate of stars annually. As you might know, the production rate of new stars in the Milky Way is less than 1, which seems impossible. But remember that galaxies have long time scales compared to humans. So the star forming in galaxies takes place typically relatively slowly. It also has a lot of bubbles and open clusters and, of course, supernova remnants from the exploding massive stars. And so there are interesting features, especially in a really large telescope or as an imager, to capture as in the current era of really incredible imaging that we have now with astrophotography. You can capture a lot of detail in this galaxy, which makes it really interesting. This is the sort of required piece of chart from Ron Stoyan's Interstellarum Deep Sky Atlas. And as I said, you can see it's literally on the border, part in each of these two constellations, Cepheus and Cygnus. And there's this relatively bright open cluster, NGC 6939, that's relatively close by, and in a very large field, you can see the two of them together.
David, while you're talking about this lovely, lovely galaxy, I wanted to interrupt to just say that it brings me back to a very happy time earlier in my life.
Yes.
When Wendy and I went up to Kitt Peak, and Wendy was going to learn how to do some astrophotography. The object she chose to photograph was 6946.
Is
and
that
she got
right?
a picture. That's right. And she got a picture very similar to this Tony Hallis image that you're showing right now.
Wow.
And it just brought back some wonderful memories. Thank you, David, for talking about 6946 today.
Well, that's fantastic, David. And I didn't remember that story. I don't know if I've ever heard that from you, but what a great connection to one of the great galaxies in the sky that story provides us. That's really great and touching. And as you can see, Tony, who's at the top of his game, of course, look at all the, H2 regions in this galaxy. It's just peppered with star forming regions here, and some nice bright and colorful foreground stars, of course, as well. So it's a really rich object and quite a good one. And as you can see, this northern Milky Way star field is really something, just peppered with stars. Here's a wide field shot by David Wills of the galaxy and its surrounding field. And it just has really nice arms that are very, very well defined, and with all of this active star formation going on in the galaxy and in our era, if you will. This is a combined Chandra with X-ray emission, the purple, and a Gemini optical image of the galaxy. Just a very different, very weird looking image of the galaxy here. Very unusual, but eye-catching, and a lot of high energy emission, of course, going on here. And I will mention that we are almost at the end now of the 50th anniversary year of Astronomy Magazine. which has been quite fun and quite a mission and quite an ordeal. I've only been at the magazine on staff for 41 of those 50 years, so I missed the first decade. But we've had a lot of fun this year with some special features. We had a big special issue that Rich Talcott did much of the work on, looking back at 60 years ago now that Martin Schmidt discovered the nature of quasars at Caltech in this month of November. So quite a number of anniversaries in various ways going on here. Quasars, of course, one of those very interesting high energy types of objects in our universe. So we also have, I will mention, Michael Bakich and I last year produced this book, A Child's Introduction to Space Exploration, trying to get kids pumped up about this new generation of space that we have. We have some friends. Our pal Alan Stern just made a voyage last week. You may have seen on social media to the lower part of space, of outer space, if you will. Very exciting time for Alan and his two comrades. And Scott, you mentioned that we have Starmus coming up, and I was just over in Bratislava doing a number of things 6 weeks ago or so, whatever it was. And this May, in May 12th through the 17th in Bratislava, which is actually very easy to get to. It's a very short drive from Vienna. So if you can get over to Vienna, Austria, a major European city, you can easily get to Bratislava, and we will have many, many, many surprises of very important scientists, not only in astronomy, but in the allied fields, Nobel Prize winners, many of them, astronaut explorers, some of the Apollo astronauts and more recent astronauts, and as Scott mentioned, some rock and roll with Brian May and some other special guest stars. The fellow who has put on the largest concert, outdoor concert in the world, that's in the Guinness Book of World Records, Jean-Michel Jarre, will be there to open the festival, among many other artists this year. And we always have our sort of family over there, Rick Wakeman and Peter Gabriel and lots of other folks who are really interested in science and art and music as well. So I encourage you to join us for Starmus. And at that point, I will turn things back over and stop sharing. And Scott, thank you for again getting through yet another galaxy.
I can never get enough of galaxies. That's why I got into astronomy in the first place. I read a book called The Red Limit by Timothy Ferris. You probably
Great
know
book.
it.
Mm-hmm.
Yep. Had a chance to meet Timothy a few times. And, guys like him, guys like you, David, and the rest of the people here that are giving talks tonight have all been inspirations to me. So, so it's and to be able to hang out with people like you and to really just enjoy it and cut loose while we're doing our thing, is a lot of fun. So,
and Scott,
anyways,
you're an inspiration to me and to all of us with all that you do for outreach as well. And we survived Chicago, and we'll have Starman. We've only just begun with science, and as Brian likes to say, you need to use both hemispheres of your brain, both science and a little bit of rock and roll.
Oh yeah. Well, you go to Starmus, you'll never forget it. So
yes, indeed.
That's for sure.
Yep.
Okay,
thanks,
so we have a question, from one of our people there in the live chat. I'm going to bring Dr. Rob Seldom back on. So here he is. Let's add you. And spotlight. Here we go. I got screen side by side right now. So the question is, and I think that this is a question a lot of people have. I certainly do. Out of all these planets, the exoplanets we've looked at, and now we're taking a very, very serious attempt to understand the spectral signatures of the atmospheres, and looking at planets that are, hundreds of light years away. I don't know what the most distant exoplanet is that we've been able to study, but I think it's exceedingly hard to try to get, to get the data out of, a couple of pixels off of the screen. But there have been hints that we're seeing some of the building blocks of life on some of these exoplanets, and we're dying to know what you think of that.
Yeah, so what I was able to, or what I've seen personally, is finding building blocks of life, such as like carbon and methane, either in molecular clouds that could be stellar nurseries to form new planets, or also on the surface of Europa. And that's one of the Galilean moons that has that nice icy surface and likely a large ocean underneath that ice where life potentially could exist on its surface. So Europa in particular is extremely exciting because if they do or were to find life on future missions, such as maybe Europa Clipper that's being launched by NASA in the next few years, that would be transformative to our entire field because right now we're admittedly using a very human-centric bias view of the universe. When we
Yeah.
look at our own solar system, we only find life here on Earth. And as far as I can tell, all life on the Earth requires liquid water to survive. So that's why we're always following the water or searching for other Earth-like planets around sun-like stars that also have Earth-like temperatures as well. When James Webb is observing these exoplanets using methods like the transit method, for example, that I discussed a little bit earlier, it is sensitive to a whole new suite of molecules that we haven't been able to observe with previous space telescopes such as Hubble. So literally every single new James Webb observation that we make is transformative science. We're finding new molecules that are changing and challenging our theory with every single observation. So it's really an exciting time to be following it right now. Whether or not James Webb finds signs of life, that's going to be really difficult, in my own opinion, to sort of definitively say whether or not a planet does have life on its surface or not. We're mostly sampling the atmospheres of these exoplanets, and we're looking for typically things that are sort of byproducts of life, such as maybe increased carbon dioxide by us exhaling or additional oxygen due to plant life doing photosynthesis and producing oxygen. But the real problem, though, is that a lot of these molecules that we're looking for can also happen abiotically without life. And being able to definitively say this is 100% life versus something that happens naturally, that's a very, very difficult thing to do. And that's one of what I would argue is one of the biggest outstanding questions of our field. What signatures do we need to look at? So if we look at something with James Webb, a planet, a moon, anything, what's sort of the bumps and wiggles? What's the signal that we then need to say that if we have this, that means we likely have life? But perhaps James Webb might get really lucky and observe that. That would be incredible. But it also might take the next generation of NASA missions, such as one that's being built right now, the Habitable Worlds Observatory. This is one of the next big NASA flagship missions that'll be launching in the 2030s, 2040s, as being explicitly to observe Earth-like planets and look for those biosignatures, those little signatures of life.
Well, that's great. Well, I hope that you're involved with those programs far into the future, and that you make some of those groundbreaking discoveries as they come up. So,
One thing I would like to do to add to what Rob has just said is to recommend that you all watch 2010, not the original. We have to watch the original too, but 2010, well, a major portion of that film deals with the ice on Europa. And in the fiction, it deals with what that amounts to as the film goes on. And they got it pretty accurately, I thought. But I do recommend that.
yeah, that's while we were getting the show ready, I was asking David when was the last time he watched 2001, which is his favorite science fiction movie, and certainly mine too. And we're probably in a club of millions of people that would say that. But I think that science fiction has really become a portal for humans to imagine what could be. Through that imagination, we built machines that allowed us to explore things and to make discoveries. And while some of the science fiction is really far flung and way, way out there, we have found things that are far flung and way, way out there. So I think that the whole process of I think science fiction plays an integral part of spurring on and inspiring people to follow a life of science. So,
And just a
anyways,
programming note, Space Odyssey 2001 is not just my favorite sci-fi movie, it's my favorite movie, period, of anything.
period. Okay,
2010 is good, and I want you to
it's
watch it
good.
to learn about the ice on Europa, but it isn't 2001. That's my favorite movie, period.
Right, right. Okay. Well, David, thank you. Thank you. And Robert, thank you for coming back on to talk about that. That's great. All righty. Up next, we have Russ Brick. He is the president of the Southern Cross Astronomical Society, and he's held that position, I think, for 8 years. Russ is, I was putting together a biography about him, trying to, I try to make a page for everybody that speaks on Global Star Party. And one of the things I learned right away is that Russ is a very modest guy, okay? But, the founder of the Southern Cross Astronomical Society was also a pretty modest guy as well. In fact, he was so modest that even though he's getting like 2,000 people a day to come and look through the telescopes, there in Miami, he didn't want people to write about him. He didn't, he didn't want to be mentioned in other people's presentations where he had a big influence. He didn't want to be mentioned there either. So I'm not sure what it's all about, but the Southern Cross Astronomical Society has been around for over a century, I think. Is that right?
Yes. 1922 they were founded.
Yeah. So it's an amazing organization made up of some super friendly people, super knowledgeable people. And they are holding their 40th anniversary of the Winter Star Party. Can you imagine that Star Party going on 40 years? So
40 years.
Yes. And so I'm going to turn this over to you, Russ, but thanks for coming on to talk about Southern Cross and the Winter Star Party and how to get involved.
Well, basically, the Star Party this year will be from February 5th to February 11th on Scout Key in the Florida Keys. The Star Party is famous for its clear, steady skies and the ability to see southern objects that you can't see from the northern latitudes. Eta Carina, specifically, the Southern Cross, of course. Also, Omega Centauri is a jewel. We have really, really an amazing view of that in the deep set southern sky where there's almost completely no light at all. It's all ocean. Weather is usually very temperate and good, clean, clear skies for astrophotography.
And you'll see a lot of astrophotographers there.
Yeah.
Right.
We have a pretty good lineup of speakers this year. Dr. Mario Moda, he'll speak about objects in the southern sky. And if he has the time, he built a 32-inch Dobsonian telescope, ground the mirror and everything.
Wow.
And he was going to give a presentation about that as well. One of our members, Martin Caminos, he's a commercial airline pilot. What you missed last year, Scott, was a new thing. We have a demonstration of celestial navigation, and he teaches you how to use a sextant.
Oh, I've actually
It's
never
actually
seen
pretty
anyone
amazing.
actually use one. So
It's a nighttime class, and he gives a very, very thorough beginning to celestial navigation.
Hmm.
It's really pretty cool.
That's cool.
Richard Wright is back with his Lucky imaging series.
Oh,
Get
yeah.
Lucky.
His amazing astrophotography as well.
Oh yeah, Randy Sheback, solar imaging,
Okay.
improving your solar images.
Hmm.
A perennial favorite, Charlie Warren. He'll be speaking about the ASIR Beginnings Guide and its time, the Zen and Art of Astronomical Pursuit. Probably be a little cosmic, I'm sure. Mike Lockwood, he always gives us a great talk. This time
Yep.
it'll be on the thermal effect on mirrors.
Hmm.
John Talbot, another astrophotographer, setting the right exposure times and adventures in imaging the unknown. Peggy Walker, she'll speak about Astronomical League observing programs, and Scott Roberts.
Uh-oh.
So, Scott, I take this opportunity to tell you that Neil has reached out to you, and we
Yep.
need to know what your presentation is going to
What the heck I'm going to talk about?
be.
Okay.
Yeah.
So, well, a few things have been swimming around in my head about this, and definitely we'll talk. I'm going to talk a little bit about telescope making, telescope design, but also what kind of drives us to go out and look at the sky, so those are the things I love to touch on.
I know we
But
missed you last year, but it was okay.
yeah, well,
was a wedding. It was
it was
okay.
my loss because this is a star party I really love. I mean, it's the warmest place you can go to when it's like frozen everywhere else.
Oh, yeah, it's
And
amazing.
I've been there when it's 80 degrees. I've gone snorkeling, during the day, stargazing at night, talking to friends that come through our tent. And just meeting really iconic astronomers, and all of you that are amateur astronomers now have learned that the amateur astronomy community is like one of the best communities you could ever hope to get involved with. They're
I totally
people,
agree. I totally agree.
I don't know how many winter star parties I've gone to. I think maybe 18 or 20 of them, something like that. And maybe more.
I think it's maybe more.
It could be. It could be.
I mean, I've
But
been
I'm
going
looking to
for
get
18
back there.
years. So.
I'm looking to get back there. It is weathered, the Winter Star Party has weathered hurricanes. It's weathered all kinds of stuff. I guess politics, but the group, the Southern Cross Astronomical Society, always makes sure that they have that site or sites. It's now the Girl Scouts camp and the Boy Scouts
And the Boy
camp,
Scouts.
right? It used to be only the Girl
Yes.
Scouts camp. So they got great facilities. Key West is 45 minutes away from the Star Party, yet the Star Party's, as you mentioned, is pretty darn dark. Okay. You can
It is.
see lots of deep sky objects with the naked eye. And then when it gets still, and this is really where it gets really amazing, is when you get arc second or sub arc second seeing. And a lot of people have never seen that before. Okay. Where you'll see these guys with massive telescopes and they are pumping up the magnification. We looked through some scopes that were set up with hundreds of magnification looking at planets, and they still looked rock steady, so
Oh, yeah.
that was a thrill. That was a
John
thrill.
Pratt and Mike Lockwood,
Yeah.
they always bring the 32.
Yeah.
And when you look through that scope at Jupiter, I swear it's like looking at a picture sometimes.
Right.
And
Yeah. So
sometimes you're right for 1 or 2 or 3, even 4 seconds. The detail is just stunning.
yeah.
You can't even describe it. You can't leave the eyepiece hoping
That's
it's going
right.
to happen again.
That's right. They'll be tearing you away from the telescope.
Oh, yeah.
But anyhow, it's all fabulous, and when if it gets, usually you have almost all the nights are clear, but occasionally they get a thunderstorm or something that comes by.
Yeah, I mean, we are at the mercy of Mother Nature, and
But
it is
it
the
goes by
Keys.
quickly. You're on that little strip of land, and it flies by. And if you stay up late enough, you'll probably have clear sky anyway. So
Well, here in Florida, we say that if you don't like the weather, wait 5 minutes, it'll
wait.
change. So,
That's right. Well, thanks very much, Russ. You guys gave us a.
oh, let me just say that if you want to come to the Star Party, go to
Sure.
our website, www.scas.org, and click the Winter Star Party tab, and then the registration tab. Scroll to the bottom of the page, and there's where you register.
Awesome. That's great. And it's a very affordable stay. I don't know if you guys have ever
Keys,
tried to stay in
without
a
a doubt.
hotel or a motel or, or camping even, like taking your RV down to the Florida Keys. It is pricey down there. You go to the Winter Star Party, you're there for it's a week, right? I mean,
Yep.
and you won't find a better bargain anywhere else than to go to
No.
this event.
Especially if especially if you tow a vehicle, you bring an RV and you tow a vehicle.
Yeah,
I mean, you could just go anywhere.
that's right.
There's really, really, really good seafood in Marathon. And then, of course, there's Key West as well.
Sure. Yeah, it's a
A
lot
nice
of fun down there.
sunset down on the pier,
Right. That's right.
or the most southerly point in the United States.
So you got to do that selfie. So
Yeah.
that's right. But if you haven't been, you got to go. And
You gotta go. You gotta
take
try
it
it at
from
least
us
once.
as amateur astronomers that love great experiences under a great sky. Winter Star Party's got it all. So
You get you down there one time, you'll be hooked. I promise.
Definitely will. Definitely will. Let's play the little video that kind of shows some of the highlights of Winter Star Party.
Come one, come all to the Southern Cross Astronomical Society's 2024 Winter Star Party, celebrating 40 years of stargazing, happening from February 5 through the 11th, 2024 on Scout Key in the beautiful Florida Keys. Get away from the cold and adjust your latitude underneath the pristine skies of southern Florida with breathtaking views of Eta Carina, the Jewel Box, the Southern Cross, Centaurus A, and of course, the magnificent Omega Centauri. Tickets will go on sale on or about October 1, 2023 at scas.org. See you there.
Right.
All right.
Thank you,
Okay.
Scott.
Thank you so much, Russ. We will see you down in the Florida Keys, but I hope to have you on a few more times before the event happens. So
I'd love to come by anytime.
Okay. All right. Great.
Thank you.
Thanks, Russ. Take care.
You too.
All righty. So up next is Steve Edberg. And David, do you want to introduce Steve?
Sure, I'd be happy to.
Great. Okay.
Yeah, as I mentioned before, Steve and I have been very close friends since the International Hollywatch days. But that's just a small part of what Steve has done with his life. He has been in charge. He took over Riverside from the late Cliff Holmes and ran it for a long, long time, the Riverside Telescope Makers Conference. And then he has done a lot of other things. He has his own collection of telescopes. He is always a brilliant thinker, conversationalist.
Mhm.
He has a wonderful, wonderful family, his wife Janet, his children, and I was honored to go to the bat mitzvah of one of them. And I've never forgotten that wonderful experience. I'm not sure what he's going to talk about tonight, but whatever it is, I can promise you it's going to be great. And now, presenting Steve Edberg.
Well, thank you, David, and Scott too. Kind of now I have a lot to live up to, David. Thanks for that. Actually, What I'm planning on talking about is not a whole discussion of alien life. I couldn't fit that into 15 minutes, and Scott is standing there or sitting with his whip hidden to make sure I'm done in 15 minutes. So I got to be really on top of this. And so, first of all, since atmospheres seem to be the general discussion here, I'm limiting my presentation to exoplanet atmospheres and a little taste of what we can think about for exoplanets in general and even finding life on them. Scott asked me to review a little bit with the International Halley Watch, and I guess it was sort of a predecessor to what Robert Zellum was talking about, the Exoplanet Watch, and that was an effort to involve the world's astronomers. It was probably the biggest event that involving the greatest number of astronomers in the world at the time, and maybe still that case. We ended up producing our archive of data of Halley's Comet from when it was first recovered in 1982 with the 200-inch Hale telescope, right up to pretty much the end of the Halley Watch around 1988. And of course, I'm still waiting for somebody to send in a new picture of Halley's Comet in the next few years when it reaches aphelion. And amateur astronomers were involved in that because it was a way to help, besides getting observations in general, whether across a wide variety of types. It was also a way of tying in the previous apparitions of the comet to 1986, and maybe a way of translating what we see in 2061 when it returns as well. And that involved visual observations as a primary way of tying that up. A friend of mine, Charles Morris, who was a major contributor to the Halley Watch, is even working now on tying CCD observations of faint comets into the visual scheme of estimating magnitudes so that we understand them better. So it was a very, very busy time with a lot of excitement and a lot of fun too, for amateurs, and I think the professionals enjoyed it as well.
Oh, absolutely. Was it the first pro-am project like that of its kind?
I'm a little hesitant to say absolutely yes, but I think so.
Yeah,
certainly
think so too.
In terms of its size, it was. We had a couple of hundred. I haven't looked at the numbers recently, I'll admit, but it was a couple of hundred of serious amateur astronomers contributing significant amounts of data. And so that was very good, and the professional community was also very widely involved, with a lot of cooperation, even with observatory directors, to make sure that at important times the cometary astronomers might be able to push some of the quasar astronomers out of the way for significant observations that were necessary. So it really was a huge community effort at that time.
Yeah, it was cool. Okay.
So let me share my screen, and if there we go. I have to just do the right thing. There we go. And I'm going to go full screen for you, I hope. There we go. Okay. So exoplanet atmospheres, how do we know? And as you can see, I am now retired, formerly at Jet Propulsion Laboratory. I served as the science manager and system scientist for the Space Interferometry Mission Astrometric Observatory, which was intended to do a huge amount of foundational astrometry necessary for everything from finding planets like Earth orbiting stars within a distance of about 10 parsecs, about 33 light years, out to cosmological measurements. and superb instrument. Unfortunately, it didn't get to fly. So with that as introduction, that's how I got acquainted with exoplanets far more deeply, and in particular with astrometry far more deeply, and discovered to my surprise that it's much more interesting than one would think. It's not just measuring positions of stars in the sky. And there's a huge amount of science that just comes from that, and that's why I call it foundational. But let me get to atmospheres and exoplanets. I borrowed this slide from, or this table from, actually, I do not remember who, but it was a collection of what can we learn. And it was, if you look at the parameter on the left side there, you see planet mass, orbit semi-major axis, orbit eccentricity, orbit inclination, orbital periods. All that says this is what you can learn about exoplanets from astrometry. And that's a lot about the planets, and something even about the systems and even their history. And it's good, interesting stuff. But if you really want to understand exoplanets, you need to know more. And so I expanded on a table that had been started by one of the experts on this, and I kind of filled it in. And this is it. I'm not going to test anybody on this, but we'll start at the bottom. There are a variety of techniques that we can use for determining the parameters, the characteristics of exoplanets. That ranges from even using microlensing, where the gravitational force around a planet or a star can actually bend the light, and from that bending we can actually determine the mass of the planet or the mass of the star that is doing that. We can measure radial velocity. We can measure and do transit photometry and spectra. We can do general astrometry. That's the learning the orbits. We can use imagers in a wide-ranging, visible to the near infrared, and separately mid-infrared, and even radio frequency. And just for fun, if you look at that far right column going up, you notice that it goes from orbit to interior, to surface, atmosphere, magnetosphere. And one of those things listed over there on the far right is artificial transmissions. And you may be wondering, well, what does that mean? That means somebody on a planet sending television out, perhaps, or Omega type navigation systems. And while you're thinking about that, I mentioned Omega because, in fact, when Galileo made one of its flybys of Earth back in the 1990s, it actually turned around and tried to see if it could figure out if there was anything happening on Earth that would indicate life. And one of the things that it discovered were these Omega transmissions. It's now been closed down. We don't want to alert the extraterrestrials, but the Omega system is a navigation system that worked worldwide. And also you can see rectangles and circles of irrigated fields and that sort of thing. So there is an indication not only of life on Earth, but of intelligent, or semi-intelligent life anyway. Technological life, how's that?
There we go.
There. And so the message here is that there's a lot we can learn about planets, including Earth-like planets, if we use full service astronomy, go across the spectrum, use all the techniques available to us. And I want to describe one of those. In particular, we'll start with planetary transits. You've all heard about Kepler and the numerous thousands of planets it has discovered, down to Earth size and smaller, as they transit their host stars. And one of the things that you have to worry about is, does that really work? And if you look at, you can see in the top left here just what happens a planet. And we've seen just in the past few years, we've seen transits of Mercury and Venus. And what they do is make a light curve. First of all, the star or our sun is at a kind of a fixed brightness, and then for a short time it decreases, goes off when the planet is silhouetted completely on the star, and then as it hits the limb and goes back up, it does that. That's different from an eclipsing binary, which you see in the red here, which goes down to some deep minimum and then comes back up. So that's why when we observe these things, we still go back and need some additional information. In the case of something like this, radial velocity would go a long way to telling us whether it was a binary star or a planet transiting, if this were not as clear or obvious as in the light curve. So that's one way. But once you can do that with telescopes, there's more you can do. And I'm bringing this up because this is a picture of the demo I'm about to do. And so I can describe this here. When you see it, you'll have a better idea of what I'm talking about. But I have this is an aquarium light with portion of one that is just standing vertically. This is the filament, a tungsten filament that emits light. And let me tell you, it's really hard to find filamentary, single filament LED lamps now. I've been looking for a long time and found them finally, but not like this. Anyway, and I want you to think of that as the star. Here you can see the spectrum of the star, and it's a nice continuous spectrum. In reality, we see spectral lines on it most of the time. This is an artist's conception of a simple spectrum of a star with hydrogen alpha, hydrogen beta, hydrogen gamma visible across from the deep blue into the red. If there's an atmosphere around a planet over here that gets in front of the star, we see a fingerprint and in this case, this is a particular kind of plastic that takes out all the magenta light and lets everything, or rather it takes out all the yellow green. You can see it missing here as it covers the star. And that is essentially what we can do when we look at transits. And so what I'm going to do is show you this live. I'd like people to get a chance. I know you're at a screen, but this works well because at least you'll see it can be really done this way. And so I'm going to have my transiting planet here. Turn on the light, and
Hey, Steve.
I have to.
Steve, I'm going to unshare your presentation so people can see this.
Okay, yeah,
Is
I'm
that
going to
okay?
do that. I got it.
Right.
There we go.
There we go. Okay.
And you'll be amused to know that I had to use a single layer of solar filter material because my star was too bright. And there it is.
Right.
You can see right over here is and that's probably me moving in the background or something. I don't know. Everything's moving in the background. This is a spectrum. And if I just put a planet through here, you can see it's coming across and it's crossing in front of the star.
Cool.
And the spectrum goes out. You can see it got blocked.
Oh, right. You can see them up on the top, left and right there.
Yeah. Now, of course, this is a demonstration. It's not a perfect replica. I can't do it, but I can come close. So here is the star's light missing while the planet is transiting. And as it goes by, it comes back out and we get, in fact, two spectra, one on each side. I'm using the left side just because that's easier to see here. So now I'm going to bring around another planet that's orbiting this star, and it's crossing in front. And you see that, in fact, there is still, and maybe I should, I'm going to leave it as is. You can see the red and yellow are making it through. It's not much getting through the blue-green, but there is certainly that same loss of color that you were seeing on the picture better. And so that is what we can look for in the real world. I'm going to turn this
That's so
back
cool.
and share my screen again. Once I find, here we go. Oh, no, there we go. Hope this is working. There we go. So here again, just to remind you, the filament and the spectrum goes black. And these are real live pictures. This is using the same whole display. It was just close up to make it a little easier to understand. So I want to show you also what can be done with pretty simple equipment. Again, here's an artist simplified spectrum, the same one actually, just maybe spread a little bit more. H alpha, H beta, H gamma, the hydrogen lines. And I have two spectra. These were made with, well, in this case, planet trails, Mars and Saturn, with a diffraction grating and just in front of a 50 or 100 millimeter focal length lens. And you can see in a couple of places some fairly strong lines. There's an iron line in here in the middle of this. There's sodium, the sodium triplet, or rather doublet, I should say, is actually here. And I'm going to show you better versions of these yet, but I want to do this. And also notice the difference between Mars, there's nothing here, and in Saturn, there's something here. That happens to be the spectrum of methane, one of the sets of spectral lines that methane provides. It's pretty weak, but it's genuinely there. And if we were to play games with reversing the color out, laying them on top of each other, we could actually subtract out all the colors, except we'd see that there is actually methane there, not just that weak value that's present. So I'm going to go show you that again. And here are these. Notice the spectral lines. That iron line is right over here. This is hydrogen beta. This is the sodium triplet, hydrogen alpha, and the sun is here. And there is that is methane in Saturn's atmosphere. All the rest is reflected sunlight, but methane is absorbing light in the atmosphere. Now, the interesting thing about this is that as I was able to try and show you, or showed you between the picture and the actual demo, that the atmosphere does take things out in transmission. And the beauty of that is, instead of getting a little signal like this, you at least have a good, strong amount of light that makes it possible to see that. And so we can look for atmospheres of planets. The other ways that we can look for planets is just at their colors. And I expect we're going to be seeing more of this coming from James Webb Space Telescope. And just look at across the solar system, Uranus and Neptune over here, very blue, Jupiter, Saturn, Titan, more mid-coloring. Venus is an odd person, Earth, so it is also, and Mercury, Mars, and the Moon are all up here in this area. So we get different spectra, and not even spectra, we don't need to, we just get colors that are different from them. We can also, with infrared telescopes, look at those atmospheres and see carbon dioxide on Venus, not something that is especially likely to be caused by life. Methane, it's argued, is a possibility, but we know that might only be on hard surface planets, not on gas giants. Ozone says there's an oxygen atmosphere, and that is very distinctive as a possible source indication of life. There are searches for biosignatures, and ozone and O3 I mentioned, liquid water, and well, CO2, O3 water altogether, and methane all suggest that that would be the case. You can model these things. That's what the brown is against the Earthshine spectrum. That's an easy way to get the spectrum of reflected spectrum of Earth using the moon as the screen. And by modeling what we think the atmosphere would be like, we can actually get a pretty good model that matches what Earth's is and would be then something we might say, notice this vegetation is included down here as well, might tell us that there is life on Earth. And again, that's been done also in the far infrared. Out the peak there is at about 20 micrometers. And we can see the contributions of carbon dioxide, ozone, water, dominant, but there's also methane and nitrogen monoxide, dinitrogen monoxide. And I don't remember if that's nitrous or nitric, so forgive me, I'm not a chemist. So I think that is about all I have. I blew it. I went too long. I'm sorry, Scott.
It's okay.
But
it was fascinating. People loved your demonstration. Steve's done a number of these things, and of course, he's a scientist, and he loves getting the information out of the spectral data, and so we've had people on before that tried to show our audience how to get involved as an amateur into collecting spectral data, and so it's not very difficult. Just like Dr. Seldom was describing, those that do astrophotography, the beautiful photography, that's a much harder effort than it is to collect data for science. So. But you do have to be disciplined in collecting your data for science. You have to be disciplined in reporting it, and that's all hallmarks of being an amateur scientist. So, but we'll have to have you on again, Steve. That was we were just getting going, I think. So,
yeah,
thank you.
You're welcome.
Thank you so much. Okay. All right. So you now know that you need to get a spectrograph. Tom Fields, who's been on here before, would be very happy to hear that. I'm suggesting, that you get a diffraction grading and start using RSpec, which is his software that makes looking at the details within a spectrum relatively easy. So you too can become a scientist. Stephen, thank you so much.
I was just doing some of that on Saturday night, in fact.
Oh, you were? Okay, yep. That's great. That's great. So is the observatory running top notch now?
It's getting closer.
Okay.
It's getting closer. Progress is made.
Very good. Very good. Thanks, Steve. Thanks for coming on.
Sure. Thank you.
All right. So I was writing in chat about, because people were talking about Halley's Comet and but it was in those years in 1985, 86 when I met Steve Edberg, and I got to see him in action, and he has only gotten better over the years. That's what I can say. And he was fantastic then. So thanks for participating. We're going to go down to the Southern Hemisphere, all the way down to Buenos Aires, to Cesar Barolo, who is going to talk about his observations from his balcony in his Southern Sky balcony presentation.
Yes, Scott, can you hear me good?
I hear you good.
Okay. Well, I was expecting that that tonight can be a cold be. Well, I thought that you can see now that it's fully cloudy.
Yes.
We was expecting more partly cloudy, but it's about the lucky things in astronomy. And
well, it's our atmosphere, right?
Yes, it's atmosphere. The idea was a point to a bright star, but the problem is that any star in the field of vision is enough bright to be visible
Mhm.
all through the clouds. It's a kind of um, clouds lower with a movement from northwest to southeast. I can show you first of all. I'll share my screen
Okay.
and I can show you how actually these clouds are moving. Well, the discussion maybe is not with a live image. First of all, I try to show you if I have something in my telescope. Well, here you are watching my screen, my camera control.
Yeah, it looks like mission control.
Yes, I'm putting again my camera. Okay. The first thing that I try is connect and connect again. As in the word, we will say, or we use the computer. Sorry. By the technical issues, problems. It's fun because, well, okay. First of all, we are trying to show something in the, if we have something in the field of view. I see that now on clouds, I appoint an area of the star Sargas. Here is a star, but it's impossible. Maybe you are not watching stars now. First of all, we have two problems where we are in a city where the light contamination, the light pollution is from the illumination of the city and reflecting to the sky, and this kind of clouds you can see that are horribly lighting.
Yes.
And
you can see it's a
well,
live image.
yeah, yes. The idea was talk about more the atmosphere, nothing. But
Right.
you know, maybe the idea was talking about maybe we can try move one star to the center, and maybe we can see something. I see one star. I don't know if you are watching something in the screen, because maybe with the transmission, the
But you have a star
yes,
on the
yes.
where the
Here and here you have 2 and 3 stars.
oh, okay. All right. So if you tracked and stacked, you could probably get a number of stars even through the clouds, I would imagine.
Yes. The area is the area of in the south is Indus. Is the area of Indus. Don't have a really so much. Let me put a smaller area, but here, okay. It's more easy. See the stars and see the effect. I'm using a little more than 1.5 seconds of exposition. more of the effect over the atmospheric condition for tonight is more about scattering, diffraction, because this is that the image of the star suffering the change in their wavefront for a condition where, for example, here you can have as now a layer of clouds, but you know, you're having maybe another optical effects like a diffraction, breaking the wavefront and the shape of the star. The star has not a shape, of course. It's about the 80 degrees, but it's more a seeing this. I think that if it's not a bright star to see the all difference effects over the image, over the wavefront of the star, we can see. But maybe I need more magnification and less clouds and a brighter star. It's the same that Stephen ever showed with a low light lamp. Maybe you don't have the all complete spectrum of something. Here we have a less information than we need to talk about. Yes, if I change this position, only I have a lot of light around the star in the background, because it's not the background of the space, it's the cloud that reflects more light.
Yeah, we can see the star.
You can see the star.
Yes.
Yeah. Yes. Yes. Have and of course that everything in the atmosphere many change our perception of the space. This is why Webb telescope and Hubble telescope is a great idea of the humanity. Many times I wrote in books that of astronomy. Well, now it's words. We lost the stars, actually, but that we are watching from the bottom of the lake. When many, I don't remember if it was in some amateur telescope making books or in the Texero books that first of all, our first limit to the quality of our image is our atmosphere, our the quantity of water in the atmosphere, the turbulence. When we are talking about the movement of different layers of air, and well, the idea tonight was talk more about seeing with a bright star, but maybe for a next occasion we can make an airy disk of image with a maybe maximum telescope and see the conditions how we can see the scene. This that is something that we can see in strong magnification, and maybe in a laboratory or maybe in a great condition that are not easy, and of course in cities is more difficult to found, is that, let me change the stop share because it's too boring the white image, sorry. Well, I can show you how these clouds are moving over this part of my country or my city. I showed you. I share the screen again. This is how we are watching the same now with the area. I was pointing my telescope to the south.
Okay,
To the south. Yes.
where
area,
are you exactly?
Here.
Right
Here,
there.
Scott.
Okay, right on
Yes,
the coast.
yes.
Okay.
I'm the part where we was watching the star is the southwest. The southwest is here.
So I have a question for you.
Tell me.
When you do have clouds, but let's say you have a bright planet up, do you generally find that the sky holds the atmosphere a bit steadier with clouds? Do you see more detail on the planet than on a perfectly clear night? Or is this just chance?
It's it's in a clear night. You tell me, well, the real thing that many times I'm hope to have a really clear or stable image of image of a planet. Me and many amateur astronomers that we are hope to have something new in the sky with a clear and cloudy night, if not very clear without clouds.
Yes.
But if you don't have a stable atmosphere, you have a mess, a disaster. It's something that I'm learned with the time to be not how do you say, first of all, I'm not optimist with the first sight of a planet. Maybe in the first time of the night to have a mixing of hot and cold weather. You have a first time that planet is clear but have a continued movement, and you don't have able to see any details. This is an effect of the atmosphere where you have a bad scene, and maybe you don't have any cloud in the sky, but it's a twilight star night where you have this effect. Is where you have a very bad image of planets. I don't know if I understood the question, Scott. I in a moment that you tell me, I forget some.
No. But I was just wondering, do you see better images of planets when there's some clouds in the sky?
Perfectly. Only to have, yes.
I've noticed this many times myself, so.
Absolutely. Do you have, the only thing that maybe can you ruin your image in talking about clouds? It's perfect that you tell me. But maybe in the opposite situation, do you have a teeny layer clouds night? Yeah. And you are watching planets, maybe the loss of light that the cloud of are filtering to you, especially observing, maybe not for photography or video, help to you to see more details. And it is, as you told me many times, despite this scattering, the diffraction that losing some details, the clouds that are losing so bright help you to see details as the storm in Jupiter and as bands or details in the Saturn belt. you're losing some details, but by contrast, to lose something of light, you are watching much better details in planets. It's maybe effects, special effects of the clouds over your perception, but it's great. It's something like a small filtering of light, enough to show you details of contrast.
Yeah.
You know, it's maybe if you measure the quality of scene or the details of resolution, maybe you are losing something, because every drop of water floating in the sky are diffracting the light. But maybe you are having a much better experience watching in this kind of nights.
Right.
Because you feel much better details about contrasting the bands or the red spot in.
Steve Edberg was chatting in our chat room here. And he says in Southern and Central California, he says alto level clouds indicate great stability in the atmosphere. I've had arc-second seeing conditions on those occasions, either through the clouds or in holes, or through the holes in them. Also, when the coastal inversion, and you would get coastal inversion sometimes, Cesar, where you are, I would think. When the coastal inversion is below his observing site, the seeing can be also very steady. So you know, the lesson here is that got some clouds, but you still got some clear sky. So you should probably go out and do some astronomy anyways. And if you're like Gary Palmer and those guys in England, where they have clouds a lot, okay?
Yes, Gary Palmer.
They often shoot deep sky objects through the holes in the clouds. So.
Yes.
Right?
Many times when you don't like to lose something that you are appreciate to watch, it's a great idea. Don't be afraid to put your telescope. Yes, don't be afraid. many times, maybe you have 10 minutes of an image and you have a great time. And maybe it's a short time in the night, but you're happy because you see something, you experiment something. And for me, sometimes in the city or with the bad weather, that Buenos Aires is a place that is not great to have all-time clear skies and the light pollutions. But you know that many times we have a great moments, and maybe we are appreciating more these moments because they're like a small jewels in the sky when we are in the holes of the clouds, in the hole in the sky. Yes, between the clouds.
Thank you, Cesar.
It's a pleasure.
Thank you so much. Okay.
Thank you to all audience. Thank you very much.
All right. Always great to have you on. Up next is Dr. Daniel Barth. Daniel has a series called How Do You Know? And that has been running now for a couple of years. And
3 years, yeah.
3 years. Okay, great. And anyways, we've got him tonight. And you are going to be talking about expanding atmospheres.
Yes. I'm going to give everyone flashbacks tonight. Do you remember when you talked about gas laws in science class, probably a chemistry class back in high school? And the teacher said, well, if we could have a sample of an ideal gas, right? What would it be like? Well, it would be well mixed. It would be essentially so much of it that if you took a sample anywhere of any imaginable workable size, it would be the same as anywhere else. And you think, oh, no such a thing exists, but it does. Atmospheres are essentially ideal gases. They are confined by nothing but gravity. And they are thoroughly mixed. And yes, there are the local specialties of our atmosphere, what we call, meteorology. That's a going science, but essentially, on a large scale, our atmosphere is very well mixed. But atmospheres also respond to those classic gas laws, like Boyle's law, pressure and volume, where you talk about, okay, if you put an atmosphere under greater pressure, it gets to be a smaller volume. You see Jupiter and Saturn, planets of similar diameter, but one is much more massive than the other. Greater gravitation, more mass, more compaction of that atmosphere. And so you get this pressure-volume relationship. The other one you probably learned about in high school chemistry was Charles' law, volume and temperature. You heat something up, it expands. All the ice engine cars thrive on Charles' law. Why you start off the ignition process, you get gases which get very hot very quickly. They expand, they drive the piston down the road you go. Planet atmospheres also work this way. When we add heat to the daylight side, we know atmospheres expand. And those of us who remember the days of AM radio, or who still do ham radio, when at night without the sun, the atmosphere contracts, it steadies, the ionosphere becomes something you can bounce a radio signal off of. So we know that heat can affect an atmosphere, but what if you had a lot of heat? Really, quite a lot. Scientists have been tracking something for a couple of years, and it's only as the data has finally come in, people are realizing what we're seeing. What we've been able to see in a star that's been quaintly named Assassin QJ or something equally fantastic is the collision of two Neptune-class planets. These things are probably between 4 and 7 Earth masses, and they actually collided in orbit in this solar system. Yes, an unbelievable amount of energy. What tipped us off that it was a planetary collision? Well, one of the things that we looked at was, gee goodness, it has a surface temperature of 700 centigrade. And it's it's about 16, it appears to be about 16 AU out. So 700 centigrade is really hot, especially for a planet. The other thing is they were able to compute the size of it. It has a diameter 750 times that of the Earth. So we're not talking about, oh, Jupiter is 12 times the diameter of the Earth, 750 times the diameter of the. So it has star-like dimensions, and yet temperatures which are far too cold. And we realized by the signature of the dust cloud boiling off, basically, that what you had was 2 planets. And what we think happened, and this is spectacular, one about 4 Earth masses, one about 7. And we think that essentially, like gas giants, as they collided, they had essentially a glancing blow and tore each other to shreds, gravitationally, tidally disrupting each other. And the 2 planetary masses reconverged a final time and smushed together about a year later. And this whole process of creating a new planet, it has 99% of the mass of the old one. This is not unlike the proto-Earth and Theia collision that created a body about 1% of our mass, which is the moon. Here you have collision of 2 Neptune-class gas or ice giants colliding and making a new, much larger planet. But what happened to that atmosphere? That collision, an incredible amount of energy. Get your physics hats on, kids. 10 to the 34th joules. 10 to the 34th power. 10, 34 more zeros. Unimaginable. That's in energy, the amount our sun puts out completely in all its spectra, solar wind, total energy output for 8 years in this single massive collision. And guess what? Charles' law, heat a gas up, it expands. Hot air balloons, Montgolfier brothers, oh no, we're going to go big. This thing expanded. These things were probably about 4 or 5 Earth diameters, as Neptune and Uranus are. And this thing went to 750 Earth diameters at 700 centigrade. And obviously, the atmosphere is going to collapse massively as it cools. Would that we had a closer seat. What would it look like when a planet's atmosphere collapses about 700-fold down onto itself as it cools off and sheds energy over the next few years? It would be a fascinating process to watch. How do the weather patterns establish themselves from essentially, let's completely randomize everything. We're going to collide the two planets and the atmosphere becomes well mixed and gigantic, a giant ball of ideal gas. But then gravity and the laws of thermodynamics take over. Charles' law, as it cools off, it contracts. And obviously, all sorts of new weather patterns, chemistry, all sorts of new things are going to sort themselves out in this new planet.
Right.
It would be fascinating to have a closer seat. But obviously, with an event that energetic, too close a seat would be not good
Close
to be
for
down
comfort.
in what Shakespeare would have called the cheap seats.
Yeah.
That might have been a bit too close for comfort. But it's interesting to think of atmospheres as dynamic gases that respond to things like temperature and pressure and all sorts of laws that go on. But fun to see things at this sort of scale.
Yeah.
Anyway,
Thank
so
you.
there you go.
Thank you. Great. That's awesome. We are getting close to our break time. We have one more talk here by Robert Reeves, but I think instead of being a 10-minute break, it's going to be like a 5-minute break. But Daniel, thank you so much for coming on. And there we are. And our next speaker is none other than Robert Reeves, and he is going to be talking about a walk through the clouds on the moon.
The moon does have an
Awesome.
atmosphere, correct?
A very tenuous one. It's one I wouldn't hold your breath over, but an atmosphere on the moon is actually on a molecular level. A molecule here, a molecule there, not much in between. But there is a detectable atmosphere on the moon that extends several thousand kilometers above the moon. This has been detected by the Lunar Reconnaissance Orbiter, which is still very active in orbit around the moon. It has the LAMP instrument on it, the Lyman alpha detector. And the unusual thing about that is it was designed to look down at the surface of the moon, looking for water ice, things like that. But Lunar Reconnaissance Orbiter is running out of attitude control fuel. So it is being controlled a lot with reaction wheels now. As a result, every now and then the reaction wheels need to be desaturated, so the spacecraft tips on its side quite a bit. And it's looking high above the moon. And the Lyman alpha, the LAMP instrument, is detecting hydrogen at very high altitudes above the moon. So there is an atmosphere on the moon, but for all intents and purposes, you can consider it a vacuum. But my talk tonight, a walk through the clouds. What I'm going to do is go through Mare Nubium on the moon, the sea of clouds, down on the southwestern corner of the moon. We're at new moon right now, so we're not going to be seeing a moon in the next couple of days. So I can pick any place on the moon I want. But I chose Mare Nubium because it's very special to me. I took a photograph of Mare Nubium with my Celestron 8, well over 10 years ago. And the photo I took indirectly led to my job with the Celestron Telescope Company. So I have a bit of affinity for that one particular image. But before we do the scary screen share experiment, two things. Something marvelous happened in my life earlier this week. I came into possession of several hundred of the original lunar orbiter prints that were used back in the 1960s to map the moon, and the mission 1, 2, and 3 were specifically for seeking out Apollo landing sites. And at my feet, I don't have a place to put them yet, but there's a huge stack of them crowding me out of my desk at my feet, and another stack on my printer table. And in about 2 weeks, I'm going to go get several hundred more pounds of them. So for somebody who has been in love with the moon as long as I have, followed the space program from the beginning, and was old enough to follow the technicalities of Apollo, having this windfall of lunar orbiter imagery fall into my lap is, I mean, it's a gold mine. Oh, let's see if I can. I've got tons of the original full-size prints put together by the U.S. Army Mapping Service.
Why does it look like there's a lattice work going
because the nature of how the images were taken, they were taken on 70 millimeter film aboard the spacecraft, and then there is a flying spot readout that shined a light through the film, and it was read by a photometer, and the varying intensity of light was then digitally or it may have been analog back then. The signal was sent to Earth, where it in turn fed into another device that shined a light on film in proportion to the signal received from the spacecraft. And it did this in a series of strips. And hold it up. It broadcast each one of these strips, and then these were manually assembled. Each band was physically pieced together and then photographed into a master negative, huge master negative, and then these huge contact prints were made from that. And that's what has been distributed to all the places that use this stuff. These particular prints were originally at the Johnson Space Center, and then after the Apollo program, NASA, in all of its infinite wisdom, just decided to throw them all away.
Okay.
So they were intercepted before they hit the dumpster, and they became the core of the material at the Lunar and Planetary Laboratory in Houston, over on Bay State Boulevard. I've been over there many times. I've pored over these very same images on their light table back in the late 80s, and now here they are. They're mine. But last May, the Lunar and Planetary Laboratory decided, well, we're going to throw all of these things away. So a group at the Corpus Christi Astronomy Club rescued them and put together complete sets, gave them out to various universities, and the remnants are all falling into my lap. So it's been quite a trip. I'm literally have my feet propped up on probably about what cost $1 million to produce. So anyway, such is life in the big city with the government. When they're finished with something, boy, they'll throw it overboard in a heartbeat. But now it's mine to enjoy and pour over and relish and compare to my own photographs. And of course,
would you share any of those digitally, or?
I have a stack of about 6 inches deep that are duplicates, and I will find good homes for them.
Nice.
So, and before we take a walk through the clouds, of course, Christmas is coming up. If you have any interest in the moon, you know anybody who has an interest in the moon, of course, go to Amazon, look for Exploring the Moon with Robert Reeves. It'll be delivered to your doorstep within 2 days. So so much for the 10-penny commercial. Let's try the screen share experiment. I'm only going to do one picture. And if I can find it. And let's hope it works. Alrighty. Wait a minute. I didn't hit screen share. Let me go back. I'm making the mistake this time. Okay, where are you? Whoops, wrong one. I make a muck out of this every time, don't I? Yeah. There we are. Okay, now I go to screen share.
Yes.
And let's see here. Hit share and hit that. And now, hopefully, you are seeing an image of Mare Nubium.
We are seeing thumbnails, but
oh, here we go again.
Mare Nubium is one of the thumbnails.
Yeah, well, I don't want a thumbnail. I want the actual thing. Stop share. Let me bring it up to full screen first. And then, now I've lost you. How do I get back to you so I can go back to screen share?
Do your control tab, and you can tab through your programs.
Control tab.
Just hit control tab like you're hitting tab, and you can see the different programs there.
Well, this is. Okay.
Is that your other laptop again?
This is the one I've used before, and it's okay. Go back to screen share. Okay, let's click on one of those. Now, thumbnails or Mare Nubium?
There you go. You did it.
Okay, great. Okay, now. We're going to stay on this one image because a walk in the clouds, Mare Nubium. The reason I like Mare Nubium so much, it is a microcosm of so many things on the moon, so many different features. There's rills, there's graben, there's complex craters, simple craters, there's ghost craters, there's just all kinds of features and some serious history too. Floor fractured craters, new craters, old. So you can see my cursor moving around, I hope?
Yes.
Good. Okay. Well, let's start up in the upper corner, right-hand corner. And, of course, bordering Mare Nubium up in the north, whoops, don't want that. Up on the northeast, we've got the triple craters Ptolemaeus, Alphonsus, and Arzachel. And these aren't necessarily associated directly with Mare Nubium, but they border right up next to it. Now, these three craters in their own right are an observational triple pair that they're not related to each other, but they're so close to each other that we observe them as a unit. Now, notice Alphonsus in the middle at the 9 o'clock, 1:30, about 4:30, there's dark spots on the inside of the crater walls. Those are volcanic ash deposits from volcanic vents that spewed this ash out over 1 billion years ago. And it is still visible today. In higher resolution pictures, you can see these little volcanic vents. They're only about 2-3 kilometers in diameter, but the ash surrounding them is larger and makes them stand out. Back in 1959, Nikolai Kozyrev got some spectra and visual observations of some sort of strange obscuration in this area that was interpreted as volcanic vents, gas venting from a volcano. Now, nobody else saw it, but the spectrograms are real. And that was so intriguing that NASA sent the Ranger 9 spacecraft to impact in Alphonsus looking for evidence of volcanism. Of course, it didn't find it. Alphonsus looked very much like it does in our views in telescopic views from Earth. But still, a little bit of space history. That was the targeted area for the Ranger 9 spacecraft back in 1965. Down on the east coast of Mare Nubium, straight wall, one of our very go away. One of our very popular sentimental favorite type features on the moon. Quickly becomes a favorite of novices, and the experienced observers come back to it again and again because it's so unique. At sunrise, like now, it casts a shadow, creating a black line feature. We're talking about this line right here. And then, of course, at sunset, I wish I would quit making that come up. At sunset, the slope of straight wall is brightly illuminated. It becomes a white line feature. Heading further south, just off the southeastern shore of Mare Nubium, look at this huge, huge crater here. This is Deslandres. It's well over 200 kilometers in diameter, and it is so old and worn that it wasn't even recognized as a crater until the 20th century, and it wasn't even named until after I was born. It was named back in the late 1940s. Before that, it was simply called Hell Plain, named after this crater right here, Hell crater, named after Father Maximilian Hell. And but today we know it as Deslandres. A little bit further south, our familiar Tycho crater, one of the youngest large craters on the moon, thought to be about 108 million years old, which means its formation occurred about the time T-Rex was roaming around on the Earth, and the flash of the impact of the asteroid that created that surely got the attention of even the dinosaurs, because it would have been spectacular. Cruising along the southern border of Mare Nubium, Tadas crater here, a floor fractured. Yes, I can enlarge it. How about that? A floor fractured crater that's been flooded with basalt from underneath, while basalt's welled up from below. The same magma chambers that fed lavas into Mare Nubium also pushed up from below, completely flooded the interior of this crater, and we can see along the northern rim of it these rills, fractures where the floor buckled up. Same thing happened to Hesiodus crater right next to it, and notice the direct center impact, the bullseye impact of a small crater within a Hesiodus. Kind of gives it an artistic effect. And then look right below the little concentric crater, Hesiodus A. Even in this lower resolution, you can clearly see there are two walls on this crater. An outer wall, which we expect on small crater or all craters, and then an inner wall, perfectly concentric. This is not a chance impact of another asteroid that struck the middle of this. This is actually a volcanic feature. There are 51 concentric craters, and they primarily hug around the edges of the Maria. And frankly, we're not sure why or how that inner concentric wall formed, but their group proximity to the basalt fields, the Maria, says it has to be volcanic. Cruising along the southern Nubium, we see these ghost craters. Here's just the very rim of a crater protruding. Another one right here, the crater Keys, Lubniansky up here, more of them up here. These ghost craters were emplaced on the Nubian basin before the lava flooding that paved over the entire Maria. So these craters are extremely old and filled up with basalt as the Nubian basin flooded. And now all we see is the very rims of their craters protruding above the basalt. We call these ghost craters, and there's a high number of them in the Nubian basin. And that tells me that the basalts within Nubium are not necessarily that deep. No more than a kilometer or so. Otherwise, these crater rims would be completely buried. Rather well, down here, right next to Keys crater, notice the little tiny shield volcano inside circle I'm making with my cursor. You can even see the caldera. Stop that. There, you can even see the little caldera in the middle of it. That's a little shield volcano, what we call Keys Pi, Pi, the like the Greek letter, and they're very typical of lunar domes, shield volcanoes on the moon. There are no tall Vesuvius-like volcanoes on the moon. They're all very shallow, only several hundred meters high, 10 to 15 kilometers wide. The slopes on Keys Pi, probably no more than about 2 degrees. We can only see it when the sun elevation is extremely low, just right after sunrise. Otherwise, they disappear. We can't see them because there's no relief. Cruising in middle of Mare Nubium, the very unusual crater Wolf. Don't quite know what to make of this one. Whether it's an impact modified central peak to the Nubian Basin, I find that probably not believable because no other basins have visible central peaks. Central peaks in a basin are probably covered over by impact melt almost immediately after the basin was formed, but more than likely just a chance crater formation that was then partially flooded with basalt. But my guess is Wolf formed on in the Nubian Basin after it was already partially flooded. So it didn't form on the floor of the Nubian Basin. It formed on an elevated, partially flooded part of it. So the rim of Wolf Crater is higher than it would be if it had been on the very floor of the basin. Therefore, it didn't become as much of a ghost crater. But still, the interior flooded, but we have this unusual heart-shaped outer rim. And then marching northward, more overlapping ghost craters. The rather well-formed complex crater Borealis. Here we see the classic form of a complex crater, terraced walls collapsed, sloping inward to the middle of the crater, complex of central peaks that rebound upward from the impact that create the crater, and the ground surge radiating outward in all directions. Borealis is too old for the ray structure to remain, like Tycho or Copernicus. But at one time, Borealis had a pretty healthy ray structure. But rays fade after about 1 billion years because of space weathering. The infall of micrometeorites churns and tills the soil and eventually covers the rays, and solar radiation also dulls them. So crater rays will go away after about 1 billion years. Good indication of crater age is if they have rays, it is less than 1 billion years old. Moving over toward the western shore, the western shore of Mare Nubium borders right against Mare Humorum, the Sea of Humidity, Sea of Rains right next to the Sea of Humidity. And let's shrink this back down and see the Harpalis rills here. These are essentially stretch marks where the surface was pulled apart by the slumping of the basalt within the Humorum Basin, off still in the shadow, but as the basalt within that basin depressed the center of the basin and all the basalt started to slump toward the middle, it stretched the surface, and pulled open these cracks. More wrong direction. More ghost craters up above, and here, following my cursor, we can see the mountain chain here, some crater rims here, Garrick crater, Perry and Bonpland, and let's shrink it down a little bit more, and Fra Mauro crater here. And of course, just north of Fra Mauro, the Apollo 14 landing site, where Alan Shepard shot as golf balls. And of course, everybody is wishing Fred Hayes, Apollo 13 astronaut, a happy birthday today. He was 90 years old, I think yesterday. And this landing area would have been where Jim Lovell and Fred Hayes would have touched down had Apollo 13 not had their incident. So happy birthday to Fred Hayes. I wish that had been you picking up the rocks up there. And Alan would have gone on a later mission. This, like I said, I was tracing out this area here. This oval is what is now called Mare Cognitum. Now, back in 1964, this used to be part of Oceanus Procellarum, which is almost entirely still in the shadow, but this was the eastern part of it. And then in the summer of 1964, we launched Ranger 7, which became our first successful moon probe. Up to that point, we'd had a miserable string of luck getting spacecraft to the moon. They'd fail one after another. Ranger 7 changed that. After that, it was nothing but success. Ranger 7 impacted in this area, which we've now renamed Mare Cognitum, the known sea, in honor of the Ranger 7 mission. As Ranger 7 got closer and closer and closer to the surface, it kept snapping pictures and transmitting them in real time until the final pictures showed details about 1 meter in diameter. The pictures showed that, yes, indeed, the lunar surface would be strong enough to support a landing spacecraft, which was good news because by then the design of the lunar lander was already frozen. It's kind of hard to do a massive redesign of it. So it validated that everything is going to be good. Garrick crater. This, let me enlarge it a little bit. This one right here, this partial ghost crater, looks like it's got a crown on its head. I remember watching the Ranger 8 pictures being broadcast on a live television special that evening. Gerard Kuiper describing them as we get closer and closer and closer to the surface, and Garrick crater looming larger and larger and larger, and finally it drifted off to the right side of the field of view because the spacecraft was on a trajectory heading in toward heading in toward what became Mare Cognitum. Before that, like I said, it was a portion of Oceanus Procellarum, but Kuiper proposed renaming it this particular area Mare Cognitum, and the IAU approved it at a record fast time. There's also this extension of Mare Nubium up here on the east side between Garrick and Perry, Bonpland, Frau Murrow, and over here on this side, Ptolemaeus crater. This bay-like extension going north here, it's unusual in that it does not have a name. Most extensions and bays protruding from the moon, from Amaria, do have a name, but this one doesn't. And I've lobbied to have it that area named Sinus Mysterium, the Bay of Mystery. But so far, I'm not getting too far with my naming campaign. So, walk around the clouds, or walk through the clouds, or whatever. Mare Nubium, the Sea of Clouds. So, I hope the next time you look down in this area of the moon, recognize some of these features, understand a little bit of the history of it. I forgot to mention Rima Hesiotis down here, this huge linear rill, which is created by a volcanic dike that pushed up from the molten core of the moon. Wow. and split the surface, and the land collapsed between the two fault lines and created this linear reel. It goes on for several hundred kilometers, and the dike didn't reach the surface as an eruption, but it did split the surface. So in the interest of not running terribly over time, I think we'll wrap it up there. Okay. And hope that next time you look in this area of the moon, remember some of these features and enjoy the view.
Thanks, Robert. That's wonderful. That's
You're
wonderful.
welcome.
You leave many of us that are not as familiar with the moon, that call ourselves amateur astronomers, a little bit in the moon dust, so to speak.
May I ask your technique is, are you doing a video and then taking the best moments of seeing out? Is that, or
yeah, that's the technique.
Yes.
Capture 5,000 videos off of a planetary camera. I can't remember which one this was. I've had a number over the years. But the technique is capture all of that, have the processing program. It used to be Registax. Nowadays we use AutoStacker, and there's a couple of others that I haven't used. But it sorts out and picks the best percentage you choose. I usually go the best 500 out of 5,000 and create a single TIFF image out of that, which I then import into Photoshop and then do the further enhancements. So it's a pretty straightforward process, and it works well for me.
Does the atmosphere change some of your results from night to night? Like potentially, you have to throw out more because
some nights it's not even worth. I look at the jello that's just quivering on my screen. Nope, it's a Netflix night. Let's go watch something on TV.
Yeah. It's a lot of patience.
Yeah. Well, for every success that I show here, there's 10 that just don't make it.
They're probably brilliant too. But
buy my book, you'll see them.
Yeah, that's right. That's right.
So thank you very much.
Being that you were talking about a Netflix night, as we go into our short break here, I want to show, and you mentioned the Lunar Reconnaissance Orbiter. The LRO website has just some amazing images in them, and one of them is a little short movie of the Apollo 11 landing site. So there's sometimes as amateur astronomers we run into naysayers that say, hey, we never went to the moon. That was faked. That was fake. That was Hollywood, right? Well, here is Apollo 11 as imaged by the Lunar Reconnaissance Orbiter.
Cool.
And the Earth and the moon are flat, right? Or no?
Not this time. So that's the descent stage.
Those are footprints, huh?
Look at this. This is the TV camera. They've got that identified in here.
Now, the Apollo 11 site is the only one that does not have a standing flag. They placed it too close and it blew over on takeoff.
It blew over. Look at this, though. The tracks created by Neil Armstrong. I mean, that's amazing.
They'll be there for a couple of thousand years.
Not a billion?
No, they'll fade after maybe 10, 20,000 years.
Wow, that's amazing.
Cool stuff. Cool stuff. Okay.
Yeah, the mountains are unbelievable when you fly inside the crater.
Well,
Yeah, I
we're
got to
back,
do the global star party
and
right now, so that's why I
wanted
can't talk.
to
I'll call you
thank
back. I'm at the global star party.
wanted to thank everyone for participating so far and making their presentations. We are coming back from Texas, where Robert Reeves lives, in my birthplace, and shooting over to Brazil to talk to Marcelo Souza of the Louis Cruels Astronomy Club and the editor of Skies Up magazine. Thank you very much, Marcello.
Hi, thank you very much for the invitation. It's a great pleasure to be here.
Thank you.
Nice to meet all of you. Let me share here my screen because I will make first a short report about what happened for the observation of the eclipse here in Brazil, in our place here. In our place, it was, if it was possible to see, we saw a partial solar eclipse, but unfortunately, we worked hard here. We got thousands of glasses to give for solar glasses to give to the population, and we visited many schools, talked with a lot of people, organized many things, but unfortunately, in the moment of the eclipse, we had a lot of clouds in the sky. I will show the images here. I would like to thank Stephen Hamsden for the donation of the glasses for us. He donated a lot of glasses, thousands of glasses. Here, we visit many schools, organize many activities in many places. We organize activity in 15 cities at the same time. We're prepared to see at least 15 cities. Here, you see, we're prepared to, if during the day it was possible, you saw, this is the day of the eclipse. We were there in many places, different places, but to see that I visited many TV shows here to talk about the eclipse here in our region. Even in Brazilian TV channels, they use the glasses to show the importance to be protected, to see the eclipses. We did what was possible, but unfortunately the weather didn't help us. Yeah, I will show part of the reports now. You see the sky. This was one day before the eclipse. Have a lot of clouds, and in the day of the eclipse was totally clouds. It wasn't possible to see the. Here is a report showing the organization for the observation of the eclipse. And this was before the eclipse. I move it forward here. She was prepared to see for the first time a solar eclipse. Another student that she was prepared to see for the first time solar eclipse here in our region. This was one of the reports, and this was the report after the moment of the eclipse. Here, this was in the same day at night. This was in the day of the eclipse. It wasn't possible to see unfortunately, to see the sun. We tried. This was the part after the eclipse.
It looks like they're having fun.
We organized video conference we show the eclipse in other places. This is not us. They use a different image people using, but we had glasses to see the observation. This wasn't here in our city because it wasn't possible to see here the solar eclipse here, partial solar eclipse here. This was in another place that we organize. We organize in many different places, but even with the weather, with many clouds, we had people that visited the places and stayed with us there to try to see something. Even for a few moments, the eclipse, but it wasn't possible. Let me go. And this is what's happening here. And we organize many activities with a lot of people in different places. This is the new generation of your astronomy group. This is the giant Mars map that produced by the Buzz Aldrin Foundation. They sent one for us here. It's the biggest Mars map that you have in the world, with 80 meters by 80 meters. It's a very big. We use in schools. People walk in the map and see the places where the rovers landed, and we show. And here is the events. These students here, not a student, they're physicists. That is Kezia. We have good news about her now, because she participates in a selection to work in the Maldives Islands.
Oh.
And she was selected, and then she work with teaching and popularizing astronomy in the Maldives Islands in January now, in January 2024. She's traveling to there, and she will stay
bring
there.
her on to Global Star Party. That would be fun.
Yes, it will be fantastic the experience for her to be there. And for us, we need to have it's not so close, but we are now beginning the preparation for the eclipse in 2027, because it will be a annular solar eclipse that you can see here in the map. We will pass near the coast here in our city. Here, Campo dos Goitacazes will be here, 2 kilometers far from the coast, deeper in the ocean. Then we need to, we are already organizing the observation. We are talking to have boats, to ships, to people, for the people, they need to travel for a best observation, 9 kilometers far from the coast in the ocean. Then we are from now trying to organize the events. Here you see, it's very close here. To the coast here where we are. Then 2027, we will try to organize a big activity here. And I hope that the weather help us. It will be in February. That is during the summer here. Here's the duration of the eclipse. February 6th. As we are talking about the atmosphere, I will finish it showing something that ever that I see and I showed in the presentations, people like to see this. Here's the planet Saturn with the ring. It's fantastic image from the Hubble, from the Cassini. But what I'm going to show here, I know that most of you already know, but ever is fantastic to remember, is the experience with when they send the Huygens probe to analyze the moon Titan. That here we can see the atmosphere of the dense atmosphere of this moon Titan, that have most of the nitrogen. You have also methane and the hydrogen. But what is fantastic is that this probe had the opportunity to land on the surface of the moon, and it showed fantastic images. And this is a video of the touchdown in January of 2005. And this is a fantastic words, different words. Here the Huygens animation showing, and then soon we are going to see real images from the probe when the probe enter and cross the atmosphere of the moon. It's a dense atmosphere. You can't see the surface of the moon. It's like Venus. And this is real images from the probe. And we can see that you have rains there, you have rivers, you have lakes, everything like you have in here in our planet.
Crazy.
The only difference is that the temperature there is below minus 200 degrees Celsius. Then in the atmosphere, you have most of them with nitrogen, methane. Then the rains is not water, with water. No? We have methane. Now you have hydrocarbons leaked at this temperature. And then you have lakes of these hydrocarbons, methane. You have rivers of these hydrocarbons. Then it's a different words. This is a real image that showed the Huygens probe landed on the surface of the moon and then send only one image from the surface and stop.
Wow.
This is the only image that you have on the surface, and these are not rocks. These are blocks of ice, water ice. It's a very different words, you know? And for us to find life there, a very small kind of life, a microbe, we need to have a different definition for life. Because it's wonderful. Not life like we see here. Well, one possibility if you have life, that the base of the life is not carbon. Maybe ammonia is a possibility to have lives with a base in ammonia. Then here are the rivers and the lakes. These are images from radar taken by the Cassini spaceship. Here you can see the rivers, lakes on the surface of this fantastic moon, Titan. And one of the lakes, this one has the name of ugly lake, that in Portuguese we call Lagoa Feia, that is named after Lagoa Feia, this lake that you have in our city in Brazil. Rosalie Lopes was here visiting us, and she said that she was chosen because it had the same shape of the lake that you have here in our city in Brazil. That's a different lake. This is the only image that you have from the surface of this moon. And the Saturn is fantastic. It's a wonderful. When we show for the people here, is what they like, to see the plants that they like is Saturn. And in 2024, we're organizing our new event in honor of this person, that João Batista de Seixas, that lived here in our city. And it was the first time in the world that sent a report about a naked eye view of the last naked eye view of the Halley comets.
Oh, wow.
Was made here in our city. He sent it to the Astronomical Society of France. And he published many things there in the beginning of the 20th century. And we are going to honor him in our next event here in April 11, 13, 2024, the 60th edition. And thank you very much.
Awesome.
Thank you for the invitation. It's a great pleasure to be here. Thank you.
Thank you very much, Marcello. Thank you. That's wonderful. Okay. All right. So up next is here. Let's do this. Marcello, thank you so much. Really, really informative and entertaining. Dan Higgins is busily preparing for the second Astropalooza program, which I think is December 2nd, if that's right. And Dan has a long history as an amateur astronomer, someone who's interested in astronomy, like most of us, since childhood. And as I recall, Dan, did you find a telescope in the attic of an apartment that you were in? Is that right?
Oh yeah, and we also
How
have
does that
Eric
story
in-
go?
We also have Eric and my co-host in there somewhere. If you get him on as well, Eric
Okay,
Watson.
all right, Eric.
So-
Hey there.
Okay, let's add you on there.
There
we
we
go.
go.
Hey, Eric.
Hey there, Scott.
Welcome to
Hi.
Global Star Party, guys.
Thanks, appreciate it.
Yeah, so
Yeah.
you guys are busy right now getting ready for this event. Tell us a little bit about Astropalooza. How did you come up with the idea to begin with? And what was the last one like? And what do you hope for this one?
Well, really, I mean, Astropalooza was kind of like a joke. It wasn't really a real thing. We were like, what are we gonna do? Let's we were in the time where NEAF was happening, wasn't happening, didn't know what was going on.
right.
COVID was going on, all this stuff was happening. So there was a void kind of there to be filled a little bit. And I think it was me, Eric, and Jason, I think, if I remember right.
Yeah, Jason too. Yeah.
We were like, well, let's see what we could do and get some people on. And and it turned out to be a 9-hour live event on YouTube last year. And I think it was so stressing that I actually ended the show with a shot of whiskey. But,
You did. You did.
But
I forgot to bring any alcohol here. So
Well, last year, and excuse me for any of the presenters that I forget, last year we had people like Charles Bracken, Dr. Christian Sass, Molly Wakeling, Nico Carver, Sean Nielsen, all the masters of Pix Insight. We had some members that made some presentations, Ernie and Josh.
Amy Little was on.
Amy Little, yeah. Am I forgetting anybody else, Eric? I don't know. I know that there's
there were so many. We had Sean Nielsen and Wayne Parker from
Wayne Parker.
From Sky Shed Pod.
Mm-hmm.
So yeah, I mean, it was a huge event.
Now, you guys mentioned NEAF. For those of you who don't know what NEAF is, it's the Northeast Astronomy Forum, and it's something we typically look towards every year. But during the COVID pandemic, it was difficult. So Dan and Eric and who else put this on?
Well, Astropalooza was, I mean, I direct the show from my house, and Eric came on. Well, Eric had the football game he had to watch, so he was late.
Had the Army Navy game going.
And Peter started off the show, but then he had to play. He was in the finals of his hockey league, so that basically just left me for about 3 hours, and then Eric came in and did the other 7 with me. It was really cool. It was really nice putting everything together because it was very well received, and it was just amazing to have so many people that actually wanted to be on, and it was just like a half an hour.
The community come together to
exactly.
Really, and it went off so well. We actually went bigger this year. I guess newer members and newer presenters
That's
yourself
good.
being one of them.
All right,
And it's,
that's
by the
upping
way,
your
just
game.
before we
Yeah.
go further, it's December 9th, not December 2nd. So December 9th. So,
Oh, it's December 9th. Okay.
yeah,
All right.
December 9th, starting at 2 p.m. Eastern and ending whenever it ends. But we have, and if I could share my screen a little bit, and if
Sure.
let me see if I could do this real quick, and screen 2 and share. And do you see? Yeah, you see it now. Okay, so you see the Astropalooza logo now?
Yep.
All right,
Yes.
good. All right. So this is Astropalooza 2. And for those of you that don't know the show, we've actually been doing the show twice a week for the past 4 years. And Eric's going to talk about something a little surprise for tomorrow night.
Okay.
But Astropalooza 2 is a yearly event that we're going to be doing every year as long as we can. And so here are some of the guests we have. Trevor Jones from Astro Backyard, Dylan
Awesome.
O'Donnell from Star Stuff, Sean, sorry, buddy, I guess your picture got broke, but Sean Nielsen, Visible Dark, Stacy Downton, Astro Stace, Charles Bracken and Dr. Sass from My Telescope are back. All the Masters of Pix Insight, Simon Lewis, Scott, and Wayne Parker on Skyshed Observatories. Plus, I didn't have any pictures, but Prima Luce Lab will be on as well, talking about what's going on over there. So it's
Great.
going to be a star-studded event. It's going to be pretty amazing. So I'm really excited to do it again, and really excited to do it with Eric again, because me and Eric have grown this friendship of ours.
Yeah.
And you know, pretty strange, but it works out, and it's really been a great time doing it with Eric and the rest of the team, and it's been
great.
awesome. So
That's great. Looks like
Yeah.
Eric's inside his observatory right now.
I am.
Go ahead, Eric. Go ahead.
I am. I'm actually, we're talking about Wayne Parker. I'm actually in my Skyshed pod right now, my X1 with my scope right now before I start imaging tonight. And yeah, we have a big event coming up. As a matter of fact, tomorrow marks episode 300 of Astro World TV.
Wow.
So it is a great milestone for us.
Yes, it is.
It's an awesome time to come onto Astro World. If you haven't been had an opportunity to check us out yet and hang out with us, hear from our viewer membership and so many other people, and just be a part of the community. I consider Astro World TV like an online astronomy club.
Oh, sure.
When it comes to astrophotography, because we primarily focus on astrophotography, but anybody can come on and, exactly. Dan and I have been at this for 4 years, and it's been a great partnership, a great friendship. And we're just a couple of crazy, guys that, just love doing what we do, love imaging and going off the rails and just having fun.
We're just two wild and crazy guys.
Wild and crazy things.
That's exactly
like taking shots after a 9-hour marathon broadcast.
Oh yeah. I mean, Eric and I have had a couple of chances of getting together when I was in Chicago for work, and came back from the Nebraska Star Party this year, and Star Fest in Canada and all that kind of stuff. And Eric, did you make it to your Star Party or no?
No, it got rained out.
Yeah,
it got rained out during the annular solar eclipse. That weekend was a washout. But yeah, and we've just had such a ball doing what we do. I mean, you've mentioned NEAF. I had the opportunity to go to NEAF for the first time and be a part of Astro World doing that and hanging out with so many other people. I know we saw so many people from Explore Scientific, other companies, just met a lot of other really, really cool people, like-minded people. So I had to see you, Scott, and spend a little time with you. That was just a blast. So I'm just looking forward to, the future and what the future holds for, Astro World.
Sure.
And I'll do. I'm going to take a page out of Robert Reeves' book with the 10-cent commercial. But something has happened since it's been a long time since we've been on GSP. Things have been
Yeah,
happening
it's
on that.
been 3 or 4 months, something like that, I think.
I
So,
think it was like right after NEEF. I think it's like almost 6.
oh, maybe. Yeah.
Yeah, so
Maybe.
it's
Yeah,
been a
maybe.
long
Yeah.
time, and things have been happening really, really fast. And Astroworld Telescope says that Astroworld TV has expanded into retail. so
Yeah.
That's true. That's
so
true.
and that
Yeah.
I haven't said. So
Yeah, so
Astroworld
now you've
Telescopes.
got a lot of it's a dynamic deal all the way around because you've got a fantastic online presence. You've got people out there that genuinely want to, like most amateur astronomers, genuinely want to help other people get better, get the results of their dreams, and now you have this retail arm where you can really recommend and make sure that they're getting the right kind of equipment. So because it does take the right gear,
It
Yep.
but
absolutely does.
not
It
only that, because you can buy gear that's not so good, and if you're a great astrophotographer, you can make it work. You just have to work harder at it. Okay. Right?
Correct.
So,
Very true.
if you have all of that together, where you have people that can guide you through, answer your questions, get you into the right kind of gear for the kind of imaging that you want to do, and there's a zillion different versions of that puzzle. Okay. So I really commend what you guys are doing. I think it's great.
Yeah,
Thank you.
and I just since I have the time and I have you on live, I just want to go publicly and say thank you personally to you, Scott, because I know I said something to you at NEEF and I spoke to you at NEEF, but I saw on a serious note. This isn't just because it's your show. Thank you so much for giving me the kick in the butt when I needed it. So that's all I want to say, and that's all I'll say.
Yeah.
You know what I mean, but
Yeah, I
but
know. I know. But no, you were already there, so
just needed to be pushed off the cliff. Yeah, I know.
sometimes we need just a little. I didn't have to push very hard. I
No,
think I
no.
used I
No,
think
no,
I
you
used
didn't
my
have to push
pinky.
very
I
hard. He was
used my
already on the
pinky
edge.
and I
Yes.
said go.
He was already on the edge, but
I know
Do
it
it.
yeah.
was.
Do it now.
Yeah,
Well, it
but
sounds
Yeah. Well,
well,
there's
it sounds like you're
people that need to be involved in this, and some of you may be listening right now. You've been thinking about the kind of life that you have, what you're doing, where your passions are and stuff. And if it's astronomy, you got to go out and just do it. You got to go out and do it, and you need to make it a strong part of your life. It may not be the only part of your life, but the number of years that we have to really put the energy and the passion into it are limited, and so you need to make it happen.
Very true.
And it really makes me happy to see your success, Dan. So that's great.
Thanks so much, man.
Yeah.
So, but don't forget the 9th. Come check us out from 2 to 10 Eastern. Come check us out tomorrow night at episode 300. We're giving away
that's
some.
Astroworld TV on YouTube, right?
Yep,
correct.
Astroworld TV on
Okay.
YouTube.
So if you go to there's a link in this for the Global Star Party, and you can see Dan Higgins. There's a bio on him, but there's a link to Astropalooza 2, and I think on both of those pages is a direct link to your Astroworld TV. So
awesome.
but it's not hard to find. Just type in Astroworld TV on the search bar of YouTube, and you'll find it.
But you got to put TV. Don't just do Astroworld. You do Astroworld, you end up with Travis Scott's song. So I'm not gonna, I'm not kicking. I've been trying to kick him off YouTube for
really?
like 4 years, and
For stealing
it's not
your
happening.
name. Yeah, that's right. That's right.
All right.
Okay. Well, great, guys. Well, thank you for coming on. And we expect to see you on often. So
Yes,
that's great.
thank you.
Be on. I'll see you next week.
Okay,
Yeah,
great.
see ya.
Take care.
Thanks,
All
Scott.
right, take care, Eric. Thanks.
Take care.
Thanks, Dan.
See ya.
Bye bye.
Okay, so we are. Let's see if we've got.
so I'm on, Scott. I'm just I'm in transit,
I
but
see
I
you're.
am
I
here.
see you're there. That's right.
Yeah. There's my
Oh yeah, I
pad.
see like a couple of little
Dots. Yeah.
dots that are might be eyes. Reflections.
Yeah.
So you're driving right now?
Yep. I am fully hands free. I
Okay.
just came from League, where now the last time, as you recall, I had ended League and I was somewhere in the game room doing a presentation. Well,
Right.
this time I'm on the road from League, where I did not have a very good League session, but it's all slowly starting to come together. So what I decided to do for this presentation, there isn't much going on. We've had cloudy skies up until last night and tonight. And so I did get some images last night of a place where that it cleared up and I did not have my main camera with me. So I tried using the iPhone. I'm going to share some iPhone photos, which is one of the things that you do when you forget to bring your good stuff because you don't expect the weather to break. Let's see, share the good camera. Every camera you have is a good
if it's
camera.
a pinhole camera, it's
photos.
a good camera. That's right.
It's a good camera. I'm going to start by sharing. Let's see. Here's a couple of images. Here's one that I'll share. I guess I can share more. I'll share this one. I'll share this one. And I'll share that one. Why not? All right. So I'm going to add those. Let's see if it works. Okay. There you go. You're looking at me trying to shoot the Cygnus region. What I did do while I was
you can see the Milky Way.
Yeah, you can see the Milky Way in there, and that's in our portal for. I didn't have my the SQML meter. I later went back on a similar night, and it ended up being a 20.9 or 21.0, so pretty good for our region here in Michigan. And because all I had was my iPhone, I went ahead and I just took pictures with the iPhone. And I did naked eye astronomy. So I tried to see if I could see the northern coal sack. I looked for stars near Cassiopeia, which I don't think I have that image. Here's another one. And you can see the plane of the galaxy heading towards Cassiopeia. And there are a couple of stars that are 4.5 to 4.9 magnitude that were visible right where Caroline's Rose is, NGC 7789. Tau, Cas, Rho Cas, and Sigma Cas. If you can see those three stars, you're in at least a portal for, your limiting magnitude is somewhere above 5. And you can see a lot more stars as well. There's another shot with those trees, and that's a shot over the lake. You can see the effect of light pollution on a sky. That this is a Great Lake. So the bright lights to the left are from Windsor, Canada. The bright lights to the right are from Port Huron, USA. And look how much light, even in an iPhone photo, you can still see all the light that's being cast up. I think that's it. I'm going to unshare if I can. Let's see. How does this work with the iPhone? Here we go. And next, I'm going to share a couple of photos that I took with the good camera. And by good camera, I mean my, let's see, ad. So here we have, it's a Milky Way shot and the clouds are moving in. This is my Canon 6D that I use for these wide angle shots. This was an attempt to recreate a Lake Hudson shot that I had taken where I could see the entire, I could see the galactic arm going down to the, at least near the horizon. There's a lot of light pollution here, but clouds can give an element to a wide angle image. Yeah, it can really beautify it. And there is a little Easter egg. So there's a close up of the region. Hercules is to the right and Aquila is to the left. This is you can't see where I'm pointing my thumb. Maybe I can zoom it in. Okay. That is what is it? Altair and Tarzan and Aquila. And that's Barnard's E, the dark nebula that should be somewhere in the center. Over here is a little Easter egg. You might see a green fuzzy patch. That is Comet, what is it? Comet Lemon, C2023H2 Lemon. That was on November 10th. That was the location of the comet. It was over here. And the nice thing about that night was I pulled out the binoculars and I spotted the comet. I could see the color and everything, the little fuzzy patch, just like it shows up in that picture. I was able to view it in 10 by 50 binoculars. It was rated as a magnitude 10 in Sky Safari Pro. I would have guessed it to be more of a magnitude 8, but either way, it showed up, and it showed up with color. So my advice to those who are out doing their, you can see the lights and everything. So my advice, if you are doing your astro imaging, I advise go out and actually look at the sky, do some binocular astronomy, do some naked eye astronomy. See how much of the night sky you actually know. And as you're gathering your frames, as you're gathering, you're taking your photos, a lot of established imagers automatically gather what they want, so they're sleeping. But if you're not sleeping and you're next to your gear or you're up, take a look at the night sky and observe with your eyes. See what you can see. And what you may find, especially if you're a wide angle imager where you're doing the whole sky, there may be something in the sky like the comet that ends up in your photo. And you may not realize it unless you pay attention to current events and you know that there's a comet in the sky. So in other words, keep looking up, even if you're doing astro imaging. It's kind of my theme going into 2024, with all my images, is make sure you take it in with your eyes and just enjoy the beauty of the night sky that you're seeing, especially if you live in an area that's always clouded out. Winter can be a tough month. It's cloudy, it's cold, but when it's clear, it's beautiful to watch. I've got a few more images for next time where I'll process that'll be the images that I took when I went back out to that site and used my Canon 6D to gather the information instead of the iPhone. Even if you have an iPhone, take pictures, see what you can do.
That's
Scott,
right.
I'll turn it back over to you.
All right. Okay. Well, thank you very much.
Thank you,
drive
Scott.
safe out there, and we'll see you
I
next
will.
week.
Hey, you almost saw my face for a second. I ran by some lights somewhere here. I think this, yeah.
There you are.
I'm going to continue.
It really is you.
Yep. See, it wasn't a recording. It was me.
It was real.
And I'm going to say this in front of all the people that are listening. Astronomy beats bowling 2-1. I do love bowling, but astronomy beats it 2-1. It's just the way it is. So go outside and look up. It'll calm your nerves after a bad night of bowling.
Oh, yeah. That's right.
All righty.
Take care, Adrian. Thanks.
It's time. And it's time for John Schwartz.
That's
my
right.
buddy.
Adrian, I have a bowling ball too. It's white like a cue ball. I call it the lunar module. It's reactive resin, and it knocks those pins silly.
cool.
I'm like you too. I love astronomy more than anything.
Yeah. And before I fully hand it off, I do have a bowling ball called Crux, which is a constellation in the side. Yeah, it's called Crux.
Like a cross.
And
right?
they've made another version. Yeah, it's the Southern Cross. They
Wow,
don't have the
that's
Southern
so
Cross
cool.
on it. It's got purple and silver. But they named it Crux. That's the one astronomically related bowling ball that I own. And I should have thrown it
the
tonight.
only one out there.
Oh, there are more. The bowling
there's more.
storm.
Well, they're round. I
they've
guess
got-
it could be planetary.
So listen to these names, Scott. Storm Bowling Company has, they have the physics. They have the proton physics.
Oh, wow.
They have the astrophysics. Those are actual names for bowling balls.
That's cool.
And I think there are a couple of others that have sort of these out of this world name. So there's, then you have Mo Pinnell, who he's done a commercial about mass and motion and putting that technology into a bowling ball. He started out with a picture of Einstein and says Einstein probably never thought about a bowling ball, but if he did, it would look like this.
Okay.
And that's how he led off with his commercial. So
on bowlingindex.com, there's an article that says on the ball, full moon, bowling balls. I guess this is a manufacturer of bowling balls, and they look like the moon.
Yeah. So you can buy a
cool.
bowling ball. Yeah, that looks like, I actually wanted to do that. I still might.
All right. I don't know if you guys out there like bowling, but some of you do. And that's one of the bowling balls for you. It certainly is the one for Robert Reeves. So
yeah, it looks like the moon. It's probably the one for me too. I need to go ahead and order that ball.
Yeah.
Then I can always, whether it hits or misses its target, it's still the moon.
So how many pounds bowling ball do you bowl with?
I throw a 15-pounder.
A 15-pounder.
16, Adrian.
16 or 15?
16. That's what I throw.
I throw 15.
All right, so 15.
He throws 16. I throw 15.
Yeah, they're only $150.
I'm gonna go get one.
You're gonna go get one, okay?
My lunar spare ball.
Bowling.
Did they have the Jackie Gleason ball, Adrian?
No, I don't have.
It's called "Fly Me to the Moon." Yeah.
Oh, okay. That's the ball I'll end up with. So yeah, we apologize to those of you listening. We've turned it into the bowling space channel.
Bowling show.
But,
that's right.
Yeah, the bowling channel. But all right, John, you better start talking about your drawings. All right, take care, gentlemen.
Nice to see you, Adrian.
Good seeing you again.
Happy Halloween, by the way. I'm really sad that we couldn't have done this on Halloween. I had a little more stuff ready to do, but I have a guest. I wanted to clear it with Scott if I could introduce my Halloween guest tonight.
Yeah, why don't you?
And hold on, Richard. Just wait a minute. You're fine. I haven't been out in a while. Okay, here he comes. Hello, everybody. It's been a long time.
Oh my God.
I want you to know the moon landing was real. I can tell you. It cost America a lot of money. I wouldn't tell a lie. I never tell a lie.
You never tell a lie.
You know,
you're not a crook.
I'm here for the election. I'm just on sabbatical right now.
Yeah, that's great.
So I'm going to turn it over to John. I just wanted to say you're doing a fine job with this Global Star Party. It's very wonderful.
Thank you very much. Thank you very much, President.
Richard, thank you so much. I appreciate it. Hey, everybody. How are you? It's John.
Hey.
I'm back. I don't like to argue with this guy because he has a lot of pull,
Oh, yeah.
I work out, but his two bodyguards, they were holding
his army of Secret Service agents. Yeah.
Yeah, but he assured me the moon landing was real. So
that's right.
It's
was.
assuring, because if it wasn't, that's one of my favorite things to look at is, the moon and the clouds together. It's like Adrian does. And it's true, when you see clouds, you think I'm kibosh. If you just check periodically, you can see the clouds open up. And I created a Halloween picture, and the universe just dropped it in the,
Yeah.
into the view. I couldn't believe it. And it's an amazing one, but I have it coming up. So let me get started. Man, I really missed this, I've been
Yeah, me too.
I love to do the outreach and dedicate time and do stuff like that. But the problem is, this is my passion, and when I do it outside, it's work, much more work than doing this. This is what I love to do. It's never work,
Yeah, this is not work.
So yeah, it took
It
me a
doesn't
while.
feel like work anyways.
No, until after you're done, then you realize you're tired.
Well,
okay, I've got to get refreshed. I'm a little rusty at this. It's been a while, right?
Mm-hmm.
So when I was putting together my I make files with the whole picture thing, so I keep a record of it.
Okay.
And I couldn't, every time I would get the pictures onto the Zoom thing, for my folder, it would dump them. If I swipe down by accident too far, it dumps them.
Yeah.
I did that like 50 times. So, and then also when you do these, it's in reverse, right? You remember that?
Yep.
That's another thing you have to keep in mind, because so I do it backwards, but I set up the thing. I did it all right. I was good. We're almost there. I missed Caesar. How's Caesar?
Yep.
He's doing good.
He's doing good. He was clouded out, so he's a little bit bummed, but
yeah, those clouds, they always get Caesar.
Well,
but I
we
mean,
all get them.
Yeah.
We all get them. So,
well, we're getting them. I love them.
If you're doing,
I love them.
yeah.
They remind me of Orion sometimes with the spectral hues that you get. I have
nebula really up close, right? I mean,
yeah, it's very similar to, like, if you've ever been on the ocean, which I have as a fisherman.
Sure.
My father would take me on some of the greatest trips, and we did go to South America, and I have to tell you how absolutely beautiful South America is, and the southern sky is
it's amazing.
I mean, I should have never waited for Omega Centauri to come up higher, because it clouded out, and guess what? I missed it, but I saw 47.
Yep.
And it was the most unbelievable one I've ever seen. With a 12-inch telescope, it was like looking at my 28-inch. I couldn't imagine. So our title is Atmosphere. This one I have shown before, but this is a real nice picture that I was blessed again when I was walking my dog. The clouds were out, and it wasn't quite this color, but the rays of light, it just fills you back with positivity and, realizing the glory and the gift and how wonderful, there's nothing bad anymore once you go outside and see something like this. But I added some stuff to it to give it that feel. And it was, basically like another planet that might have had a methane atmosphere or a little different atmosphere with crystals of ice that come down and they sparkle, and the rays of light from their twin sun. I kind of visualize these, but the atmosphere is so critical for life. It's indicative of the magnetic field that protects us, keeps our air, our water in. It gives us the air we breathe, and the air plants need too. And basically, it's the giver of life, an atmosphere. These are just a few pictures when I walk my dog that I've been honored to capture and share. The spectral little, just the clouds, the beauty of the atmosphere. This was an acrylic painting I did of the beach.
Wow.
And it's a real loose style, so you have to go way back to look at it. It was a departure from my.
It looks like a photograph though from the
Yeah.
screen. It's
Thank
very
you.
nice.
Yeah, I've looked at some of mine on there and they don't look as good. But the resolution, this was an actual painting. That's why it appears better, because it photographed better than some of the digital stuff doesn't look the same.
Mm-hmm.
This was one morning I was just getting started to work early, and I was kind of bummed out. You know, it's early and I missed my family. Had to go to work early. And there this came up. Just
Oh yeah.
it washed away the day. It was a beautiful start.
Yeah.
These are similar. These would be considered macro clouds. And, you know, with Orion Nebula back in the day, Herschel and Tycho and mostly the 17th century guys, there was a lot of guys that sailed, you know, to navigate the world. And they used a sextant and looked at the stars, but they also saw the most beautiful clouds and, you know, skies, crystal blue with these flocks of sheep, the macro clouds. And Herschel had said that the clouds in Orion reminded him of the macro clouds that he saw at sea. So, you know, atmospheres, it could be considered a small atmosphere, you know. When the star takes that material, they have an atmosphere, and then when it dies, it blows it off. New life is created. This is just, you know, our atmosphere. Look at the beautiful planet setting, looking through there, some stars, and then the ocean. This was a trip I took with my father in Zihuatanejo, and we got off the plane, took another plane, little plane. I was scared because it was small. And we end up on this island in Zihuatanejo, and it's this little teeny town with this hotel, and there's all those birds or crickets chirping and lizards, and it was just enchanted, you know. And we went down to the beach. We still had our suitcases in our hand, and we set them down and sat down, my uncle and my brother and I, and this was what we witnessed, is that view. I tried to capture it the best from memory. You know, that's just straight out of my head. So here's another cloud I captured, just the amazing shapes. That almost looks like the Seattle Seahawks, the head in the middle, the bird head kind of thing. But, you know, with clouds, you can see whatever you want. You know, it's that paradilia is, I think, what it's called, is what Salvador Dali would see hidden shapes within.
Oh, sure.
And that's a common thing. So whenever you go out and look at the clouds, I mean, you can see amazing things that, you know, your eye and your mind will turn it into from the paradilia. You know, I've had some amazing rainbows in the last couple of years. It just seems like whenever we have a rainbow, I'm there. This one was really cool. I added the moon to it because I thought that would be a great view to see. A moonbow, which I have seen. But this was really cool. It had like 6 bands, and it made a complete half of the McDonald's emblem. This was another red sky at night, our atmosphere, you know, because of the angle of impact on the sunlight as the sun's setting, it's looking through much more atmosphere. And therefore, you know, the particles turn the color of the light to a hue of red, because it's almost like looking through dust. It's obscured and pushed to the other end of the spectrum. Look at this rainbow. It was sideways. I've never seen one like that coming out of the tree.
Yeah.
I mean, I just see the most amazing rainbows, probably because I'm always looking up, you know, looking for that amazing.
You see a lot of stuff when you keep looking up, you know. But
yeah, I mean,
I just do it when I'm driving, so it's not.
Yeah, don't do that.
I know, don't do that. I know.
So I saw something
Keep
the other
eyes on
night.
the road.
I was looking at, you know, I'm always looking for the mothership. You know that. And if you don't look, you won't see it. You never know when you're going to see it.
Yeah, of course.
So I'm looking and I go, there it is. It's there. It's no colored lights I've ever seen. It's got like a whitish pink light and a red light. And it's like, it's huge. And it's like moving super slow, like it's hovering. I'm like, I got to pull over. So I pull over, get out of the car, and It's the fire helicopter.
Mhm.
Wasn't the mothership. But it was really weird because when you're driving, it just doesn't appear to move. But yeah, that is dangerous. I wouldn't recommend it.
Right.
This was the same day that I took that moonbow one, but this was the other side of the rainbow, and it went across the palm trees. And I was trying not to get soaked, but I couldn't get the right shot. So I had to run out and just stand in it until I could get this.
Yeah.
But man,
Pretty
the
intense.
atmosphere, look at the beautiful things that this atmosphere produces for us. It just gives us so much. It's life. It's everything. I mean,
Yes.
plus air is free. I love that.
Air's free.
Another weird sunbow kind of thing in these clouds. I don't know if people call these chemtrails. I just think what these are a lot of times is when jets fly really high up, that little long trail you see, that's an indicator there's a lot of moisture.
Oh,
Like
yeah.
if you're observing and you see like a trail from a jet that goes across the sky, you should probably pack it up.
Sure.
Your views are going to be not sharp. They'll probably be blown out. But these are amazing too. The light was coming through, and that was when I was walking my little buddy. This is just a wonderful moon one I did. I remastered. It's a sketch, digital painted.
No.
This was just the other day. I was asking for a good one for this, for the atmosphere.
Yeah.
And boom, look at the rays in the clouds.
Yeah. That's
It
cool.
just, man, to be there, if you don't look up, you don't ever see this stuff. And, a lot of times you forget, or you just get so consumed with your day-to-day thing. And
Yeah.
this is a
Sitting on
reset.
some little crazy problem that you think you have, but
You go outside and I look at that and I just say to myself, John, look at this.
Yeah, which you can't really remember what the problem was, okay? But you remember this, okay?
This is
This
the
shows how
problem
it's
solver.
more important.
I call this perspective.
Yes.
It gives me perspective of the glory, just how of a magical thing that this is, our life and this planet.
It's majestic. It's awesome.
It's a miracle. I mean, it's the greatest thing. There couldn't be, and I guess maybe if you can fly into space, your spirit, and float around and look at all the stuff I can't see up close, then I'm in, But I don't want to leave everybody. This was my friend shot, Mark Penderson, who used to work at Woodland Hills. This was I showed him a storm cloud. He goes, John, you haven't seen a storm cloud. This is Colorado.
Mm-hmm.
And that came over, I think, Pikes Peak, and this weird cloud came in, and then it got black, and he said it was like the worst storm he'd ever seen. So the atmosphere can hurt and kill too, like hurricanes and typhoons and storms. I mean, not only is it a giver, and it gives us a lot of things we need, water and light and oxygen, but it can also hurt you pretty bad with tornadoes and weather phenomenon, lightning and hurricanes. Don't want to mess with Mother Nature.
Right.
The moon, like that fellow was saying, I forgot his name. What was his name again? The guy that wrote the book. He's amazing.
Robert Reed.
Robert.
Yeah.
So I wanted to go. I was going to say that, I was watching something, and there is a small atmosphere on the moon. And maybe on the South Pole, in some of the dark side, some of the craters haven't seen sunlight in many years, like probably hundreds of thousands of years, maybe. I'm not quite sure. But so there could be water ice. They've picked up spectral traces of that. And they also have detected there's an atmosphere. I wonder if that could explain some of those lights, it could be electrical, statical, like in our atmosphere. It could be some kind of a particle interaction or a field, And then Venus, our twin planet. roughly pretty close in size, but that's too close to the sun, and the atmosphere turned into a greenhouse, where the clouds, and it doesn't allow the heat out. So it just turned into literally a inferno, like a acid planet. And, not really good for life as we know it, perhaps, but you never know. I mean, there's life at the bottom of the ocean in those vents that boils water. So there very well could be life there, or even on Jupiter's moon, because it's an ice moon. There could be thermal vents, because those are very thermally challenged because of the grip of Jupiter. Look at Io and the volcanism, because it's like taffy. When it gets around Jupiter, it's just twisted it up, and that thing's getting hot. So I would imagine there could be a good chance for life underwater. Water could be considered like an atmosphere, similar, right?
Yeah, I mean, our atmosphere is basically a water atmosphere, so
this was one of the best views of Venus I've had. That was from that trip from Mount Pinos when I went. And hold on a minute, my little buddy is very impatient right now. So when we were looking, we stayed up all night that night, and I was looking at the blue snowball at 7 a.m. with that Lumicon Gen 303 filter. And Orion, I have never seen Orion, the trapezium separated. So here's a great bit of information for those of you who want to look at the planets and get your best view. And it's just before the sun comes up and just after sunset. You get this weird moment of clarity, the stabilization, where because of the brighter color, you don't have that stark contrast between black and white. So the details really come out in color. So for instance, if you were to look at Jupiter, you could catch some amazing bands, and the colors are rich, much richer than when the sky is dark, because the contrast is too stark. Your eyes are, it's like an astrophoto. It blows out the cones that can see the faint, But anyway, so this is what was happening. I mean, I was still going. So I'm like, this is amazing. And then my legs cramped up. That was 2 days straight. I tried to sleep. I barely did because I have my dog. But, 2 days on that ladder of the 28, it'll kill you. Here's another one of Venus I had. Great view, very stable. That's the good thing about our location for planetary work. You have very stable onshore flows, so you get good planetary viewing typically. But that can change in a second, as Richard says. That's the good thing about having that video. You can dump the bad ones. This thing was like so far away. I used an 18-inch Starmaster Zambudo primary f 4.3 with the paracore. And this was the view I got. And I forget how many arc seconds, but this thing was so far away. There was hardly any detail. When I showed this to my friend, he goes, that looks like more detail than I saw in the 60-inch. And I used an 18-inch telescope, but it was much less affected by the atmosphere. I've shown this one. This is the one that I created with the same telescope. This was from the transit when the moon covered Mars. And Mars does have a pretty substantial atmosphere, more than people think, but it's still very thin, and it wouldn't sustain much other than the biggest dust storm you could ever find, which, sometimes you'll be looking at Mars and you go, why can't I see anything? And it's because the winds on there are so bad that these giant, like habus, I guess you would call it, or monsoonal, in Arizona, they get these things. They're red dust clouds. They just come in and they're deadly.
Oh yeah, I've tried to drive through some before, and it's very difficult. They just tell you to stop.
Plus, it's bad for your lungs. You don't want to breathe that.
Right.
Here's another shot of Mars I did. This was through the 60, and it was one of the best views I ever had of Mars. That 60-inch is for the planets and planetary nebulas. this again was from Wilson. That was our night.
Oh, wow.
You remember we looked, that was
I
a great night.
remember. Yeah.
That was unbelievable night. That was just like we were seeing it, probably better in the, this was from Mount Pinos with my 28 inch. And I can tell you something about this one. The red spot there is a giant cyclone. And those other clouds are moving in a direction. I think they're opposite directions. But when that red spot hits those clouds, the vortice and the power of that storm, they just get pushed right around it, like it just like passing it by, like you're driving on the freeway and a car goes by. That storm is so powerful to do that to that air mass.
Yeah.
You couldn't imagine being in that thing. But, and, the cool thing about Jupiter is if it was able to get more of the mass that if the sun didn't gobble up, if it left just a little bit less, the Jupiter could have been a star. It basically has the same, basic composition and elements as a star, but unfortunately it didn't get fed enough material to cause the fission to have gravity collapse on itself. But I mean, I would say it's, similar to a dwarf, like a red dwarf, but it's not hot at all. It is hot, actually, right? It's pretty hot in there.
Pretty hot.
This again, Jupiter and Saturn has an atmosphere, and they're like monitoring that constantly. But something's going on both. They're changing constantly. That hexagonal storm on Saturn.
Yeah, that is so.
That is weird, man.
Study.
And then, so when I was at Mount Pinos, when I did that Jupiter shot, we were having a major shootout between all the telescopes, and I had a little trick up my sleeve. I had an off aperture mask, so I put it on, and I brought the binoviewers out. So it was like a 10-inch f/15 or something.
Right.
And putting that mask on, it got so sharp. And those clouds, I've never seen those clouds. The bottom section of the globe was a green, like a pale green, yellow, like an ochre in color. And then the storms were like a gray white, and they were on the bottom, and they looked like clouds. This was actually our view from our live broadcast on the Great Conjunction. This was my sketch that I made from that video clip. Of course, I
That's cool.
just used the video for position. I had to repaint everything, but this is a sketch.
Very nice.
And,
it was
and
so
that was
spectacular to see those two planets in one eyepiece field of view.
Yeah. Did you see Venus and the moon the other day?
No,
that
I did not.
Yes, they were like right next to each other. And I heard in Europe that they were almost touching. It went behind.
That's cool.
I always wanted to see that for real. Like the one Russian flag has the crescent moon with a star. I think that's what they're emanating. And then this was the Saturn view.
Beautiful.
There's a hint of those really white clouds, but in the eyepiece, it was hard to draw that because it was gone. I was like in awe. This is my latest sketch that I've finally been able to get it good enough to show. It's not done yet. It's never done. They're never done.
They're never done.
But this is Saturn opposition from this year. So that was in August, I think on the 28th. It's a great night. I just looked at Saturn. In the hexagon, you can see there's a little, I used a technique on this that I learned in art school. It's just the lighting, the way you make stuff pop, like that front ring. So I had to just draw this ever so faint. It took like 500 tries to make it blend seamless and be nice and straight, because it's freehand. Where the iPad, I can use Procreate, and if you draw a straight line and keep your finger touched, it snaps into a perfectly straight line. Or if any curve or radius you do, boom. But it's so easy. I get much more pleasure doing this freehand because it's so much harder.
Sure.
So I'm pretty proud of it. I like it. It's a good view.
Yeah.
There's another version. So when I do these, I do mock-ups. I may have 20, 30, 40 different versions of different things I apply or shading, and then I'll save them, and I don't like it, or I'll dump it. And then I keep going back and forth. It's pretty bad. I mean, I'm never satisfied. I want these perfect.
That's what separates you between people that draw for fun and a real artist. So,
if we're going to do this or do anything, you do it. You know how to do it. We knock it out of the park, because a lot of the stuff I'm enriching, the kids, and they're blown away, and it's just, the hobby just brings people together, and the kids need more nowadays. They need more stuff like this, like astronomy, and getting out there and experiencing things that are like really happening, like right now, and not on a screen. But I mean, it's all good. Everything. I've been on the screen a lot more than I thought I ever would be. I think this was Neowise, so with our atmosphere has protected us from a lot of things. I mean,
so much, every day.
Those meteorites you see, if they didn't burn up, that would be like someone shooting you. It would just go right through your body, and then you just fall down. It would be a pinhole, but it would,
Yeah, it definitely protects us in so many ways, and we just take it for granted. We wake up in the morning with our alarm clocks, and we're racing to get our coffee, and you go start up the vehicle, and you're thinking about a zillion things about work or things you got to do for your home, family, all those things, and you got to do those things. You do. Okay? But
you got to be responsible.
You can take 2 seconds and take a deep breath of air and think about how amazing it is that you're alive and you're experiencing this, and just for a moment, just understand that all things are possible, so
is it not amazing to see Orion coming up?
It's amazing. And just remember some of the things that you understand as an astronomer. We're flying on this planet. We are it's a miracle that we're even here, so and that doesn't take very long at all to kind of let that sink in, and then you can
that's what I've been doing
and worry about your problems.
I was at the store, and I see this poor elderly lady fighting with the cart, and I was like, let me get this for you.
Yeah.
And then I help some people get their material in. I've been blessed with this physique. I work at it, but you know what? I like to help people when they're struggling with lifting stuff. And I accidentally smashed up the guy's drywall, the corners, because I pushed a little too hard. I didn't take him off a sheet at a time. I just pushed like a stack of 6 sheets up and in off the dolly, which was not smart because I could have blown something out, but I got it in quick, so that was good.
Yeah.
This one was again, I want to say thank you, because that refractor, it's so sharp that when I look at the sun, I see the fulcula.
Detail. It's amazing.
Yeah, that was the total eclipse, the last one we were supposed to have, remember?
Yeah.
But it was only partial here, and it was cloudy, and I came out, and I'm like, please let it clear. Don't do this to me now. I'm like, and then I go inside, I go, the eclipse. I call my kids and my wife, and they come out, and it's clear. And I'm like, it was just marine layer. It burned off. But, these sunspots are bigger than the Earth. You can actually see the mountains on the moon. And, that instrument is a precision instrument. And, I love using it for the lunar, the detail. I wonder what Richard's shooting with. I didn't get that. Is he using a refractor or a reflector? Richard Reeves.
Richard Reeves is using a Celestron Schmidt-Cassegrain.
Wow.
Yep.
Well, that's the advantage of being able to use that program Sky Stacker, because, like you said, you're dumping out the bad, and in what is it, in 30 frames per second you get with video. So that's 30 pictures, and out of those 30 you have micro seeing, moments of perfect seeing where everything's dead still. You stop time for that 100th of a second. So that's what I think he does, because those pictures are like the LRO. They're so sharp for a Schmidt-Cassegrain. That's absolutely amazing. This is Able 36, a weird planetary kind of bipolar. But it took the good filter, a DGM filter, and a lot of power and a great night. I did that one for cloudy nights. Of course, we've seen this. I've been working on it since, because I'm never satisfied. I have several versions here, so I'm going to just run them through. Stars have atmospheres. When they burn all the critical elements, they run out of hydrogen and all the, what is it else? Helium. There's a couple, but when it converts down to cobalt, you better run, because that's when it's going to blow. I was looking at Betelgeuse and I'm like thinking to myself, what if that blows up? And then, because they said it'd be like brighter than the moon, right? Maybe.
I don't know.
And it might, like this one. It's a little more colored version. And then this is the later one I did. I toned down some of the stars. I try to paint the stars in color, like what I'm seeing, because I do see color in my scope. Like I can see color in the Trifid, color in the Dumbbell, the Swan, most of the bigger nebulas, amazing colors in Orion. The Crab had some great views of the Crab. This one was using some Malincam, data. I call it data. It's just, I added what I saw from the screen. You record that, and then you look at that, and I can put it in the side-by-side mode on my Procreate. So I literally have on the same screen my drawing and then the photograph, and I can extract out. And you want to be clear about that when you're doing that, because it's misleading to say, oh, this is what I saw on my telescope. And with light pollution in the atmosphere, it takes away from a lot of that, light. Those photons have been traveling for eons. Like, I think, how long ago? This is like 1,600 light years, or how many years?
Crab, right? So
yes. How many?
So it was recorded by the Chinese. They saw the supernova in.
It was daytime star.
I think it's 1054.
1054. So how many years did that light travel before it reached us?
Yeah, I'll find out.
And it's changing,
Oh,
and
it's constant. In 10 years, there's a guy who did a 10-year time lapse.
Wow.
Okay, and you can see the
pulsar
in the center spinning, and you can see the cloud expanding, and this is only 10 years. I mean, a monumental image. But
I wonder how big that star was. If it was as big as Betelgeuse or bigger. So I want to go into the story about the eclipse. So I've been, I'm lost without this global star party, because I'm not
that's
current.
Cool. Look.
Yeah. So
the Crab Nebula,
I had to walk my dog and get some sunshine and some cloud views. And I go out, and all of a sudden I'm looking at this is another thing, folks. Great trick. If you ever want to verify the eclipse, you just look at the shadows coming out of the trees, and they look like crescent moons. But what that really is, it's a crescent sun, because the moon is in front of it. So when I saw that, I started to like hyperventilate. I'm out, dude. We got to go home now. My dog, he's all ready to go on this huge rock. I go, we're going back, and I had to drag him back. He was pissed, but So this is what I first I did. I stopped there and I'm trying to look at the sun, which don't do this. It's not smart. I mean, you can look at it, like a welding torch, it's similar. But if you look at it just a split second too long or under magnification, magnification will burn your eye. It'll damage your cornea and probably fry your retina. But even naked eye, it's not smart. Don't do it. I had sunglasses on. I squinted, but I'm dumb enough to stare at the sun. I go, is it an eclipse? And it's like, I could barely detect there were some clouds and that. And I had a weird view. I was like, wow, that's cool, but I can't quite see it. Let me see. So I put my hand up with my camera obscura. And lo and behold, I confirmed it. So you can make a pinhole camera, piece of paper, just to do it. You can also take your telescope, a little refractor, 60 millimeter, and shoot the diagonal onto a piece of paper, in the shade. Try to put a shade over it, and then you can see some beautiful detail, sunspots, just afocal reflected onto paper. Now, this one I colored just to give you an idea of the real view. Now, this was actually done with only cell phone, and then some of the details I added, I used the 80 millimeter to get the sunspots. That was with a Bader, the Bader filter, Astro Solar. It's a mylar, like a plastic silver. It gives you a bluish tint. I just went back and recolored it. This would be what you would see like back in the day when you got a full aperture glass solar filter from Thousand Oaks. And, the glass gives you a natural yellow orange hue. That was a nice cast that it gave, but I think the Bader has a little better contrast. But this was the Bader. Now, the crows. So I got the crows flying in front of my thing. We have crows here. I have pictures of them circling and just flying around. Every night and every morning, they go from one end of the valley to the other. And I found out where they go. There's a little shopping center. I will say this, don't park your car there at night because, you'll have a primer car, just white. You'll have to get it painted again. So this is cool. I have fun with this, I just was able to.
That's cool. This is
a
photograph or a painting?
It's a combo. Okay. But mostly it's using cell phone, my cell phone. This new Samsung cell phone is amazing. It's a 200 megapixel. This part of it wasn't even done with the telescope. I just put my filter over the cell phone camera. So if you have those glasses, you can put those glasses over your cell phone and take some amazing.
Oh yeah.
And then I use Photoshop Express. It's free, and it has a bunch of levels and sharpness, contrast, clarity, and all these features that you just play with the toggle. And that's how I do the renditions when I clean them up. It's amazing what I can do with that. Here's the final result combined. So I was seeing these clouds. This is when I'm squinting at it like a very not smart person would do. And then when I zoomed in on my phone with that filter, I could really see it. I got some really amazing sunspots. They were actually showing detail. That was with an 80 millimeter, my little 80 millimeter trusty Orion. I set that up because it takes a second, but I missed the eclipse. I wanted to get that thing in totality when it's maximum. But it's pretty cool, right? Different view. You never see clouds. Sure. That's a squinted view right there. So I just, I was gifted to be able to create this and share it. I don't know. For me, I'm like, I love this. This is like, for me, a postcard or something to heaven. Oh, yeah. But and I saw the annular, and a friend of mine, Lisa Schwartz, Lisa, she works with the college, Moore Park College. She's very, she's really into outreach, and she worked at Griffith, but they did a picture of the annular eclipse in her hand, the total one, where it's a ring, the red ring. It was such a cool picture to see. She's holding her hand out like this, and the eclipse is on it. This was my Halloween one. I really love Halloween because I'm an artist and I wanted to, do something special. This was my gift I got. I added the bats. Those were my wife's Halloween bats. They stuck on the window. I just took some pictures of them and then I put them in. And the moon and the clouds, and it makes like a skull face, right? You see it?
Yeah.
The pareidolia, the skull.
Yeah,
Somebody
I
told
see
me
it.
that, but I saw it and I was like, this is so cool.
Once you see it, you can't unsee it.
Yeah, and Adrian would love this. And like one of the Ray said that, man, you can't stop Adrian. And he's right, because you know what? Just because it's cloudy, it doesn't mean, I mean, if it's clouded out and you know it's a marine layer, there's no point. But if you see broken clouds, it's one of the greatest opportunity to see the moon in the clouds is something that it's spiritual.
That's true.
And there's so many different ways it looks. I've been blown away every time I see a different one. So this is all of us. We do pumpkins. I did with my granddaughter. That's her pumpkin. Of course, Mama helped her with it. And then Patrick, my son-in-law, the father, that's his on the left. And Sandy always makes a happy one, you know, because she's a happy mom and happy with the baby, and we're all carving.
Mm-hmm.
Of course, I was working on a picture and they're yelling at me and I go, okay, I'm coming. And I come down and you know which one's mine. It's the scary one. But anyway, so I always try to do it. I used to be the pumpkin carving champion of Simi Valley, like for years in a row, and then we stopped doing it. But this was a cool one. This was freehand sketch from, you know, looking at a picture, of course. But on a pumpkin, that's hard to do. And then I'm so meticulous about it. Has to 2 hours with the pumpkin. My wife was yelling at me, get out here now. So we go outside and light it. We take the picture. This was a sketch from the picture. And then we got hit with the worst Santa Ana winds. So when morning came, we all went out. They were going to work and I was saying goodbye to them. And every pumpkin was shriveled up because we cut a lot out of them and the heads was so dry, they just were shrunken in.
Yeah.
So mine, the lips were closed. It looked like a 90-year-old gremlin guy. My poor pumpkin. I didn't even barely get to show it on Halloween. I had to rebuild it with toothpicks and it's still fried. But so this was the Halloween moon rising through the palm trees out front. And then I put my scary face on it and the stars for a special Halloween moon rising for the Global Star Party. I know it's gone, but I really love Halloween because it's cool. Fun for me. And I wanted to do some more gags. You know, I was trying to ask the wife what I could dress as. Again, this was last year's. We had so fun. Everybody was gone, the kids, and the wife goes, come on, let's carve the pumpkins. It was like we were two little kids again.
Yeah.
Together, and it was a magical moment. It was special. And then we lit them up. She gave me the eyes. She had these plastic eyes and I added them. And so, yeah. That's scary pumpkin, man.
That is a scary pumpkin. That's true.
That one was totally done from my head, you know.
Jeez.
This was my costume. I asked her, what do you think? Commander Schwarzkopf of the USS New Horizons. What do you That's stupid. Okay. I go, how about Commander Sprock? I want to be a Vulcan.
Yep.
So I just went as a rock star.
There you go.
I had my wig on and fake tattoos. You know, some guys came up to me and go, dude, we thought you were like some girl bodybuilder. You're hot. I'm like, dude, please don't tell me that. I don't want to hear that. I think they were talking about.
Yeah, let's get back to the
yeah, sorry. Well, that's the finish of the Halloween. We're back. So this is
Okay,
my
all right.
Orion. I have many versions of Orion. I'm infatuated with Orion. I couldn't imagine looking at it through William Herschel.
This is a drawing, right?
This is a sketch. This is years. This is one version. I don't know which one I'm going to enter yet because I'm too hard on myself. But maybe I can get an idea if they want to chat it, say, hey, this one looks good. What do you think? And then I'll make a choice. I'm going to enter the Cloudy Nights contest. I want to start the year by winning and finish the year by winning. And Orion's a winner. And it's just coming up at night now. And the Running Man's in there and Orion. And I think NGC 1999. You can party like it's 1999 with NGC. That's a great one. This is another version.
Yeah.
That's not my contest one. This is another one. It could be. This was an earlier rendition of that one. That's how far it developed from this. The first one you said you liked.
Mm-hmm.
This was the green version, like the ring. You know, your eye typically sees a bluish green cast. You know, in the 28, you do see color for sure. And on good nights with this, even a small refractor, you can see color in Orion, pink and green. This is my winning one, I think. This is the one I like the best. It's subtle. I've got a nice color in there. You know, that's as much color as you're going to see on your best night from Pinos with like the 28 and the 32. I'm also blessed to be able to use a 32-inch telescope, which is super fast, f3, Lockwood. Then there's this version, more of a stark. And the trap stars.
Nice. Look at that.
The trap stars are really the trap stars. So I stayed up that night, I told you, and we were looking at with a good oxygen filter. You know, you could use. Do you make those oxygen filters as well, Scott? Or
we have nebular filters, and we have
those will do the same.
Yes,
but the ones with the more of the darker, you know, like some of the oxygen ones, they put a darker cast. They don't transmit as much light.
That's true because they're extremely narrow band.
That's when you use
line
them
filters, you know. So.
And that they only allow a certain wavelength of light through, right? So it knocks out all the solar light.
Right.
So this was cool. So I want to say I'm looking at Orion, and that's where this concept was derived from, is the clouds. I was seeing inside the head like this. It's illuminated. I call it a head. It's like an eagle. It just reminds me of an eagle. I got the spikes in the stars from the spider, the astrosystem spider. The trapezium I was looking at later, and that's what I sketched from to get the perfect, you know, spread on them from the real McCoy. Mm-hmm. And then look at the cloud, how it's drizzling down on and that, you know, that's cold gas that's just in the hot, you know, light, and was it the emission from those stars is like pushing those clouds away, and it's heavier because it's cold, and it's just like dry ice. It's just drizzling down like that. And so with those filters, they add a lot of contrast to the dust cloud, the dark filamentary stuff. That's what this was trying to portray. Mm-hmm. And I'll tell you something, every line I put on there I'd erase because I didn't like the way it looked. I mean, I had a general idea, an outline, but a lot of that's ad lib later. So it'll help to go to one of Mirko's pictures and look at it, which I'm going to show you. But you see you don't usually see that kind of detail in the wing or the arm, because with the daylight, the oxygen filter, I don't know what it is. We even looked at the blue snowball at 7 o'clock in the morning. It was daylight because I kept my go-to on. Mm-hmm. Now this is another version of that. This one I like because I brought it into Procreate and I really cleaned it up, you know, made it smooth, and I changed the orientation of it and kind of softened it, darkened it down a little, because in the eyepiece, this is more reminiscent of what you're going to see. Mm-hmm. You know, maybe a little brighter, but I tone them down because I want to do some that look like the real thing. So you try to, you know, you don't, astrophotography makes it a lot brighter. You don't see that kind of detail. That's the same picture, different orientation. Trapezium, look.
Yeah.
So those macro clouds were above the trap stars and around it. That's what he was referring to, William Herschel, although he was using a 40-foot telescope in pristine skies. But really good view. This was Merkel's shot from Anza Borrego of Orion with a 32-inch. And look at how many stars.
Oh, there's a lot.
And I mean, I bet you back in the day, that 40-inch scope with that kind of seeing and no light pollution, it must have been pretty close to that.
Sure.
That is an amazing shot, right? Look at that majestic cloud. And wow, yeah, we're blessed, man. That's one of the best nebulas out there. Another just a little different enhancement technique, but
yeah,
isn't that amazing?
For northern and southern hemisphere observers.
Yeah. You know, it was weird when I was in South America, I was looking at Orion in the north and the moon too. And this was what I tried to draw from what I was seeing. So again, with Jupiter and Saturn in the twilight moments before, dawn and dusk is when you get those really great moments of stabilization, good seeing, and extremely nice color. Now, this I noticed the little stars, the bottom star, the F star, was orange, more orange. I didn't finish this one all the way because I was working on other ones, and the other ones were bluish white, but the little one on the bottom had more of a reddish hue. You could see that in the daylight. This is with I think a 6 ethos with the 28 at 4.3. So I was probably up there, probably 500-600. And the image scale is amazing, but I've never seen it separated like that at night. Again, it's that contrast thing. So it's a great time to try to see stuff. I remember you told me a story that you were talking to Jack Newton when you were at Mead, and he said, "Hey, Scott, how are you?" He goes, "Guess what I'm looking at?" "What?" "The stars in the Big Dipper." I'm like, "What?" That's crazy. Mm-hmm. But anyway, that was pretty impressive. I wanted to try it. But I used the go-to because I stayed up all night. My go-to was still on. So that's the beauty of staying up all night.
Yeah.
This is my progression on M33, which is out right now. Great galaxy for all of you at Triangulum. It's probably starting to go away quicker, but it's still there. And, with probably a 3-inch telescope, you could see it in dark enough sky. It's quite a nice galaxy. That's in our local group too, right? Smaller though than the Milky Way. It's an amazing galaxy. Very low surface brightness. This was a great night again we had. This is my M81. I always get these mixed up. M81 Bodes. Is that right? Or is it the other way around? I screwed it up again.
M81?
82 is the cigar. Right? 81 and 82, they're connected. I'll get that. This is one rendering, one version that I did. It's a pretty amazing galaxy. Same thing.
It was discovered by Johann Elert Bode on December 31st, 1774.
With this galaxy,
Bode's galaxy,
visually, it doesn't reveal like you would think. I mean, it's actually more spectacular than the other one, 81, but it's just 81 is so unique, and the plasma coming out of the core, it just has a very unique starburst galaxy is what it is, and the quality of it, it's a beauty, one of the showpiece. And so this, I was able to finally get one of the views that on certain nights everything aligns, like you're seeing temperature, and when it snaps in, it's like magic just settled over the parking lot, and every telescope on the field is amazing, and you're seeing a lot more of the spiral separation. Usually it's a lot more opaque and just soft, because it takes very good optics, extreme aperture, and killer eyepieces, and then conditions. You need conditions, that are gonna give you that once in a lifetime view. That may have been one of the best views I've ever had of those two objects.
Mm-hmm.
And a photograph, you should see what it does. It's amazing. So here was the combination of the two together. So this is what you can see with a nice wide field view.
Yeah.
And if you do it with a astro camera, you'll probably have to mosaic it to get both in the same field of view, unless you have a huge chip, and then it doesn't matter. But that's what's nice about drawing too. It really teaches you how to use your peripheral vision, and then you dark adapt, and you confirm that indeed you did see that detail, so you can add it in there.
Yeah.
And a lot of times it might not be exactly what you saw, but you try to get it close. And I had one that I was working on. I want to tell you, I had cracked the Da Vinci Code. This might have been one of my greatest, and I deleted it. I think it was like 8 hours. I was gonna save it. I told myself, you should save this one real soon, because you know what happens. And right after I thought that, it happened.
What happened?
It kicked me off.
Oh.
And you know what I say? John, practice makes perfect. And it's okay. Then I don't get mad. It's just practice. You have to practice.
Yeah.
And I'm getting close to the end. I hope I didn't go too long. I missed this. I really enjoyed doing this for everyone and sharing my stuff. I don't know, if I couldn't share it, it wouldn't even be worth doing, really.
That's what it makes.
And
makes it all worthwhile.
that's what I want to do, is just try to brighten up, and think about others too, and help out and put a smile on someone's face, make them laugh, make them enjoy, or bring them back to the realization of, look at this gift I've got, this little buddy. It's like a child almost, and he doesn't bark and stuff, and he loves astronomy. He always goes with me. I've been putting him in my moon shots because he's always there. He doesn't care. He just wants to hang out.
Sure.
Kind of like I like hanging out when I'm doing astronomy, and it's just a good companionship, and under the stars together.
Right.
But anyway, thank you so much. I really
thank you very
appreciate it.
much. Thank you.
Yeah.
Thanks. And
I appreciate it.
Yep. Thank you so much. Take care.
My
John.
background is atmosphere. It's kind of a meld of the horse head and a planet, an imaginary place where they have a nebula similar to ours on their planet.
Yeah.
They're looking out and wondering just like us.
Yeah.
And
So
as they say,
nice couple of messages here. John Ray saying, thank you for returning with the GSP. I really appreciate your commitment to amateur astronomy, enrichment, and outreach through this digital medium. Thank you, John, for tuning in.
Thanks, Ray.
And yeah, so it's great audience and great presenters, and there's our little dog there. So.
That's Bosco. He's been nipping at my leg the whole time. He wanted to say hi.
That's right. Okay, so
thank you so much.
Wraps it up. Thank you so much, and we are going to end up with our outros for the program. We'll be back next Tuesday with the 136th Global Star Party. So tune in, and we'll have a great program lined up for you. So
thank you, everybody. And keep looking up, you know, get
Keep
out there.
looking up. That's
the
right.
planets are perfect right now. Jupiter and Venus are there, and Orion is ready. It's just getting up early enough to where you can get it done early and take a look. And each night you can see it appears different depending on your seeing, you know.
Yeah, our ever-changing solar system. So,
and it's beautiful. I can't tell you guys how amazing that is to look at.
All right. So take
Thank you.
care, and
Have a great
we
evening.
will. Yep, we'll see you next week. Take care.
Come one, come all to the Southern Cross Astronomical Society's 2024 Winter Star Party, celebrating 40 years of stargazing, happening from February 5 through the 11th, 2024 on Scout Key in the beautiful Florida Keys. Get away from the cold and adjust your latitude underneath the pristine skies of southern Florida with breathtaking views of Eta Carina, the Jewel Box, the Southern Cross, Centaurus A, and of course, the magnificent Omega Centauri. Tickets will go on sale on or about October 1, 2023 at scaz.org. See you there.
Are your eclipse glasses safe for looking at the sun? Let's check to see if your eclipse glasses can handle the heat or if they need to stay inside. First off, never check your eclipse glasses with the sun. That's a good way to injure your eyes. Take your eclipse glasses and find a bright light, like a lamp or a flashlight. Hold your eclipse glasses up to the light and look through them. The light will appear extremely dim or not appear at all when looking through the glasses. For example, you should only be able to see the filament of a light bulb, but not the glow surrounding the bulb. Also, if your eclipse glasses have any marks or scratches on them, don't use them. If you have older eclipse glasses from a previous eclipse, give them a check to make sure they haven't been damaged or scratched. All safe eclipse glasses will meet the ISO 12312-2 standard. It's best to store eclipse glasses in a safe place where they won't become scratched or punctured. Remember, never look at the sun without eclipse glasses or a solar filter. Be safe and happy sun viewing, everyone.
Targus is on a mission to create smart, sustainable accessories to empower you to do more by using less. sustainability shouldn't be a barrier to tech. It should be seamlessly integrated with how we work, play, and live. That's why we're on a journey to create a suite of tech accessories where smart design and sustainability are inextricably linked. We're doing more, designing smarter, dreaming bigger, and using less. Introducing the EcoSmart range of bags and accessories, a collection of products that not only puts the planet and people first by using a host of eco-friendly innovations and materials, but enables you to do more with your device while protecting and empowering your future. It's our planet, your future. Together with Targus, you've got this.